And that's the only philosophy, open science that we can follow to achieve what we want. Yeah. Before we start with your annual report, I thought it would be interesting for you to see what we have accomplished from a higher level. Yeah, as running NITheCS, you need to have some kind of dashboards to see what's going on. Yeah, and the most important dashboard is what comes out of the research programs. Yeah, and so this year you have published 233 papers, yeah, which is very nice, yeah, and we are still on a trajectory of increasing papers, yeah, and here I fitted an exponential curve, yeah, we are still growing exponentially, yeah. Considering that we have 400 associates in NITheCS, it's not really overwhelming. Yeah, because it's half a paper per associate. Yeah? But we don't have 400 active participants in the research programs. Yeah? So let's assume that we have more than 200 active participants in the research program. So it's probably one paper per associate. Yeah? And that is important because that means that we contribute a lot to the productivity of the paper productivity of the country, yeah? And we generate essentially a lot of publication funds, yeah? And NITheCS doesn't claim them; they all go to your university back into your cost centers, yeah. So this is very nice. I was hoping we would break the 250 this year so that the exponential curve would be perfect, yeah? But I'm sure next year we will be somewhere here, yeah, if we keep going like we're doing now. Yeah? No, I did this exercise because NRF wants all this information that I'm sharing with you. Yeah? So, what is also interesting, this is, there is that tool from Elsevier called SciVal, yeah? So you can, in Scopus, find the publication, and SciVal does all the statistics. Yeah? So what is very interesting that 7% of our papers are in the top 10% most cited papers worldwide. These are just papers published last year and cited last year. Yeah, it would be a little bit different if we do it, but this is what NRF wants in the annual report. Yeah, so that's interesting. That means we're not doing too bad. Yeah, if 10% of our papers are in the top 10% of most cited publications, I don't think that's bad. So I think we should be proud of it. Yeah. The other thing, interesting statistics is that around a quarter of our paper is in the top 10% of journals. Yeah? Again, according to SciVal and CiteScore and blah, blah, blah. Yeah? So that's not bad. And we have a few ones in the top 1% of journals. Yeah? Would be nice if it would increase, but I think that the fact that we have a quarter of our paper in the top 10% of journals, I think is also a sign of the quality of what we do. Yeah. So, once you have the statistics, you can see which were the 5 most cited papers of last year. Yeah. This I was involved with, but this is a little bit of a once-off. This was our famous quantum communication experiment. Yeah, at least got a lot of citation. Yeah. Then we have this gentleman, Andronikos, yeah, who is a NITheCS associate through DUT Stellenbosch. I'm not sure exactly what. He has 2 in the top 5. Yeah, this is from Charles Kruger, who is in the bio kind of area. Yeah, and here are this is Ying Shema, our astro guys. Also have one in there. Yeah, this is just a snapshot. Good morning. Good morning. Sorry, we just started because otherwise we were worried that we would be late. Yeah. Okay. Now, Another thing that NRF wants is to know how the publications are distributed according to the quartile of the journals. Yeah? I showed you already, we have 25% of the almost half our papers, yeah, are in the top, in the quartile one according to Saival and Saimago and those kind of statistics. Yeah? We have 60 papers, which is another quarter in Q2, yeah, and a few in Q3 and very few in Q4, yeah. And it would be really nice if going forward we could kill Q4, yeah. That would be really very nice. But I think that we are doing well, yeah, because 3/4 of the papers are between Q1 and Q2. Yeah, I think that's quite nice. But we should work towards killing Q4. Yeah, that would be, sometimes I gave a look at the 11 papers in Q4, and some of them are some proceedings of some journal, that you end up because you attended a conference. So sometimes it's not really your fault. So they're not necessarily all predatory journals. Yeah? These are all Scopus journals, so there shouldn't be any predatory journals in here. Yeah? But anyway, I think this is again testimony of the good quality of what we do, yeah, because 3/4 of the papers are in Q1 and Q2. Then I think we should be fairly proud of it. Yeah? So, who published the most? Yeah, and I looked up the top 5 or top 6. Those that have at least more than 3 or more papers in Q1 journals. Yeah, this Andronikos, I have no idea how he managed it. He's always in collaborations. Yeah? So that might explain it. Amare was very productive. He has 8 papers in there. I managed 5, Yingshema 4. Here we have 3, and Nico Orce at University of Western Cape had 3. Yeah, and then there are many more people with 2, 1, and so on and so forth. Yeah, but I think it's. I'm not sure that we should aim each of us of having 15, because I don't know how people manage to do that. It seems fairly impossible to me, but anyway, it's okay. Yeah. So where are these publications? Yeah? This is now the Scopus categorization, the category. Yeah? Half of our papers are still in physics and astrophysics. Yeah? Followed by mathematics. Yeah? More than 1/4 of the papers is in mathematics, and the rest is scattered across all the other disciplines. Yeah? I tried with, I think with ChatGPT, I uploaded all our list of publications. I told you to categorize them in our 8 disciplines. Yeah? And more or less, it represents what we had before. Yeah? So between theoretical physics and astrophysics, it's almost half. Yeah? Mathematics has maybe also 1/4 or so. Yeah? And bio, the numbers are the number of papers. Yeah? Mathematics 35, the bio guys 20, data science has 28, statistics 6, finance 17, earth and climate also 17. Yeah? This is just ChatGPT. I didn't audit it. Yeah? But it will be a first order approximation that it is more or less correct. Yeah. Other thing that NRF wants to know is how we collaborate geographically. Yeah? So 60% of our papers have some kind of international collaborator. Yeah? 1/3 is only national collaboration. Yeah? And I think I like the fact that 90% of our papers are some collaboration of folks, because that is what we're trying to achieve here. And less than 10% a single author paper, yeah, because that's also fine, and we respect that, yeah. But it's obvious that 90% of what we do is some kind of collaboration within the research program, or even with people from outside. Yeah, so that's also very nice. Then the other thing I can do for fun, and I think Cyber does it for you, and do this key phrase, yeah. And you see, the most common keyword is cosmology, yeah. Then there is a little bit of everything as well, yeah. From Monte Carlo methods to polymers and dynamical systems and so on and so forth. Yeah, so this is just for fun. Yeah. The one thing that I want to mention that has been told to me by NRF and the STI is the following. Yeah, we all have this transformation mandate. Yeah, but it's not just the head count transformation, yeah, of the statistics of where the people involved get from and our students are from, yeah. They want the STI and NRF, NITheCS to be leading in transforming the way we do science in South Africa, yeah. And by that is, they mean exactly what we are trying to do, yeah. So we are sort of the prototype of how they see that science should be done in South Africa, yeah. To in the spirit of open science, collaborate, yeah, and try to solve relevant problems together, yeah, and not one by one fighting different battles. Yeah? And I think this is very important that we keep it in mind in what we do, yeah, because that's where the national science strategy is going. And they're sort of using us as the test case. Yeah? We are sort of the prototype, yeah, of how in future science has to be done in South Africa. Yeah? And I agree, because we are in the global picture, we are small fry. Yeah? We don't have the means to compete with our colleagues at Oxford, Harvard, MIT. Yeah? They have many more resources that we don't have. Yeah? So if we don't share what we have and try to make it go further than just splitting it in mini parcels, yeah, we won't go anywhere. Yeah. Okay, I think I will finish here, and later at the end, when we have time for discussion, I will add some technical things about budgets and things like that are relevant from April onwards, when this next financial year starts. Yeah. Do you have any question at this stage? Please.
Are the papers you mentioned pulled from our reports, or are the ones that actually cite?
Yes, no, these, I went in Scopus and I downloaded paper that have NITheCS in the affiliations.
So if somebody forgot to put the NITheCS, you would not have seen
I don't have that. Yeah, yeah. So that, I have a slide on that for later this afternoon, yeah, to please put the NITheCS affiliation on the papers. Yeah. And I discovered there are still some of us, and I won't mention name, that put NITEP on the publication. Yeah? And some write National Institute of Theoretical and Computational Science. Yeah? So if you add all those options in the search opus, you find a few papers more. Yeah? So we are Institute 4, not of. Please, Kevin.
I've got a funny story. Just submitted a paper, and they insisted that NITheCS, which is my second affiliation, have a city. And I said to them, no, it's a nationwide.
We will discuss it later, because we had a problem that Ilya raised a few weeks ago. Yeah, and I have the solution to that problem, but I want to keep it for the final.
I made my own solution, so I hope you don't mind.
Yeah, no, that's as long as there is NITheCS, I'm happy. Yeah, but there is no problem, and I checked it with the STI and NRF, and they checked it with the AGT to add, for instance, NITheCS at your UK is a 10 branch. Yeah.
Well, that's what I did.
And then you add University of
I said, take it in node.
Yeah.
Durban.
Yes. We have now official permission. Earlier they didn't want it. Now I told them that we had a problem at some stage, so they're happy that we do it. But I will share it at the end. Yeah. Okay. Then enough from me. Yeah. Yeah. So the next speaker is our. Let me give you the microphone. Here we go. And we plan to have half an hour for every speaker. And maybe you speak 25 minutes. We have
I'll try. I haven't timed it, so we'll see. It just stop me if
I will.
it's going on too much. Yeah.
I think you're gonna take it. Yeah.
Right. On this point, there is no.
Yeah.
It's Sunday.
Yeah, Sunday.
Yes. But okay, it might not be.
Yeah.
And why is this? And this one? Then it's
Yeah.
well, but I'm not using a laptop. How many? Probably this. Oh, okay. Yeah.
Just have a look. I think it's just press that button where you point. It's not that.
Well, it's not my mouse at the cloud. Seems, but I don't know. Maybe it's okay. Because this one is not showing.
The screen sharing just froze. Second.
Oh, all right. Let's start.
You can go forward.
Yes. Good. And then one more. Okay. All right. Yeah, I guess let me start. So thanks to NITheCS for bringing us here for these presentations. I've already enjoyed some of the discussions I've been having this morning and yesterday with colleagues from the other focus areas. So it is nice that we get to hear what everybody else is doing. So I'll be presenting the annual report of the Decoding the Universe focus area. So Vishnu, who is the main focus area coordinator, is on sabbatical in the US this year. So I'm the deputy coordinator, so I'm doing it instead. But I must say that even though I've been basing this on the report that Vishnu prepared, the responsibility for the slides is mine, and I'm not sure if Vishnu will agree with everything that I have to say, but we'll see about that. All right, so let's start with what is the focus area about, and we are. And maybe let's start from the very beginning, just set the framework. I'm not going to spend, of course, too much time with on the background, but just to give a little bit, frame the focus area. So, this is the standard model, okay? We're all happy with this, and this is something that is very well tested and something that we spend some time teaching our undergrads and our master students, and it's kind of straightforward how to do computations here. And in particular, let me focus on this part here. So that's these are the gluons of the standard model. So these are the particles that carry the force of the strong interactions, QCD. Don't worry too much about the group theory here, but the point is that a relatively good graduate student can do non-trivial kind of perturbative computations in this theory with a little bit of work and a bit of computational power. However, the problem with this description, which has been very well tested at colliders, is that it is a weakly coupled description of what is happening. Right, so it is basically telling you what are the constituents of matter, of the universe, but at weak couple. What we really would like to understand, and that is one of the ultimate goals, I would say, in high energy theory, is not this as such, but this. Right, so these are the bound states formed from these fundamental particles that were on the previous slide. And as part of them, you have the mesons, the pions, the kaons. You have the proton and the neutron. There's called N because it's the nucleon. And you have excited states of this. And we would really like to be able to start from first principles, knowing what the quarks are and the interactions between the quarks, and just, get this diagram. Now, what this diagram is a comparison between experiment and lattice. So the lattice is a computational method, computational QCD method. I'm going to discuss more about it in the coming slides to be able to, numerically solve the problem. And as you can see, it's actually, rather a very good way of solving the problem. However, this is hiding a lot of information. The lattice is very good for quantities that are time independent, things where you can go to Euclidean space, so forget about time. And it's not that great for dynamical questions. So things like decay times and the rates and all of these things. So we need more than just the lattice, even though the lattice is a very important part of what people do, especially also in our focus area. So we want to be able to get some non-perturbative understanding of gauge theory. So gauge theory is a class of theories where QCD is one of these. Right, so how do you achieve it? Well, one way that has been very fruitful in the past 20-something years is this idea of holography. And now I'm switching kind of gears, and I'm now going to be talking about gravity as a holographic theory first. So it was known for a long time that when you want to study quantum gravity, it behaves very differently to the other theories that we are familiar with. And in particular, gravity, which is relevant, of course, for quantum gravity for black holes and early universe, it does not have any local degrees of freedom. So if you have a gravitational system, all the degrees of freedom are sitting on the boundary of that system. That's kind of something well established from studies from the 60s, Penrose and so on, of black holes and black hole information, that it's only really the horizon of the black hole. But actually, that's true for any quantum gravity system. It's not only black holes that have this property. But black holes are the test case here. And the idea is that, any area, you make a region around it, and you split it into Planck area kind of squares, and that's how the entropy is supposed to come through. However, this is not very practical. This is a nice picture, but it's not a very practical picture. And that's where string theory comes in. So string theory, very briefly, is a theory which, does the job quite nicely of quantizing gravity. However, it has its own problems, including the fact that it has to live in more dimensions. It wants more symmetry, like supersymmetry in particular. I'm not going to discuss it very much. But the idea is that you live in 10 dimensions. This is us. We live in 4 dimensions. But there is an internal topological space called the Calabi-Yau or some variation of that, which is giving you a lot of information about the actual theory of the standard model that lives in these dimensions. It has many problems, string theory, and one of the biggest ones is that it has too many solutions. So it's very hard to pick out what is the correct string theory, let's say, what is the one which actually describes our world, because they're just probably infinitely many, but definitely 10 to the a very large number of examples you can construct. And then you get into some kind of rabbit hole of thinking anthropically, saying, well, there is no real dynamics behind this. We're just in the universe. There's many universes, and we're just in one universe, which is the appropriate one for humans to kind of evolve. But these are things that our focus area is tackling in a very strong way. and I will come to that when I look at the papers. But it also, at the same time, you can think of it as purely mathematically. It does explain or provide a very good understanding of holography, and that happens through these words that you probably will see a lot of times in the slides. This ADS-CFT correspondence. The idea there in string theory is that you can have a gravitational theory completely equivalent to a theory without gravity, but in one dimension less. So this is a kind of my drawing of how this works. So you have what we call an ADS space, and the de Sitter space is basically a higher dimensional version of a hyperbola. And then on the boundary of this hyperbola, which is a four-dimensional space here, that's where we live. So that's where the quantum field theory lives. There's no gravity here, there is gravity here, but these are not things that you add up. Either you think of this picture or you think of that picture, and they're completely equivalent. So when you see the word holography from now on in the presentation, this is more or less the picture I'm thinking of, that we are trying to understand something about strongly coupled quantum field theory. So this problem with the hadrons and how they arise, what are their masses and so on. We're trying to understand it using the gravitational picture, or we're trying to use something we know about field theory to understand the gravity better, to understand quantum gravity better. Because these are kind of mutually exclusive things. Either you understand one side, then it's very difficult to understand the other sides at the same coupling. It's a strong weak duality. So if this is easy to understand, then this is difficult. If you go to a regime where this is difficult to understand, then this is easy. So it's very useful, but they're not valid at the same time. And that's one of the challenges. If you have something on top of this, which is called integrability, integrable structures, then you can actually go through an interpolation between strong and weak coupling, and you can follow the theory as you evolve between the two regimes. So going from weakly coupled gauge theory to strongly coupled gauge theory, and being able to follow observables non-perturbatively. And that has been done for some examples, and it is really beautiful, but it's only for very specific, kind of model theories that have a lot of symbol. All right, so let's go to some of the questions that our focus area is studying. So I mentioned the entropy of black holes. That's always a big challenge that everybody is trying to make progress in, and there has been a lot of progress in the past few years. I'll mention some of these works. We're also trying to understand better this landscape problem of too many solutions. So trying to get a better handle of which ones are the right ones, what's the principle behind them. Can we learn something about quantum gravity using this holographic approach just more generally? This holography worked for very supersymmetric theories. They're not very realistic. Can we do something more? Can we learn about more interesting kind of, approaching QCD, which is the eventual goal? But that's, of course, the ultimate goal that we're not going to get to in the next 5 or 10 years. But it's something that we're hoping to eventually understand analytically. So basically getting full analytic control of a strongly coupled, realistic, four-dimensional theory is, the goal, I would say. All right, so that's the general questions. And in terms of our goals, okay, so we can split roughly our focus area into people who are, although these are kind of overlapping, but thinking about black holes and holography and quantum gravity, that's definitely a big part. You can also try to understand supersymmetric gauge theory in an exact way. So using techniques like integrability or things that are called indices, superconformal indices. These are quantities that do not change under small deformations. Then you can try to simulate quantum gravity with simple quantum systems. And when I say simulate, I mean, maybe not yet, but at least building the technology to be able to do this in a quantum computer. So using actual qubits in a quantum computer to predict something about quantum gravity using the holographic prescription. So we call it quantum gravity in the lab. Then there is some non-perturbative gauge theory. So this is the lattice approach I was telling you earlier, or variations of that, where you take gauge theory and you just put it on a lattice. You discretize space-time, and then you try to solve as a proper computational problem what the behavior of your theory is. We have people doing heavy ion physics. So heavy ions are very linked to experiment. That's what people do at Alice, at CERN, at RIC, in Brookhaven, and so on. When you scatter some heavy particles like lead on lead, and so on, and trying to see, put this matter at high temperature. And this has strong links to early universe cosmology, because that is kind of a way to go back to some of the early stages of the Big Bang. So it's something which is experimental, but also has very important theoretical repercussions. And finally, there's a part of our focus area who's focusing on data-driven mathematics. So this is using the new techniques coming from machine learning and all that for mathematical discovery. Which, of course, given the focus area, with a focus on applications, maybe not just proving theorems, but more in the context of, okay, what is this going to tell us about particle physics? Okay, so we have 10 work packages in our focus area. This is a rough list. Okay, the first 5. So I've colored people who are based at WITS in blue. I'm at UP, and green is UCT, and orange there is UJ, and so on. So you can see that, okay, this is kind of quite heavily blue. So it is a focus area which is mainly based at WITS for historical reasons, but there's many other of us who are also doing quite a lot of work. And so roughly you can see there is okay, sorry, I went maybe one go before. So there is studies of black holes and holography. There's quantum gravity in the lab, simulations. A lot of complexity. I think we're going to hear more about that from Jaco, who's at the back here. So there is a bit of overlap, I would say, between our focus area and some of the stuff of the, I guess, quantum technologies focus area that Jaco is representing. So large N gauge theory, applied string theory. So I mostly come into these exact results in quantum field theory and trying to get more real world understanding of gauge theory. This automated discovery has to do more with applying machine learning and stuff to do some things that we cannot do currently in mathematical physics. And also there's a big and perhaps the most diverse kind of work package is the one where they study heavy ions and particle physics, and it's diverse in terms of both gender but also representation in different universities. All right, so these are the kind of core people. Of course, there's many more people, postdocs and so on, but these are just the core people that I'm counting. So some numbers. Okay, so the publications that I found in the report, which was all prepared by me, was something like 32 or so. I think it's undercounting because definitely some of the ones that we could have counted in our focus area are perhaps more counted in the quantum technologies ones. But or in cosmology, or so there's other different focus areas that it's a bit hard to really tell. And the same with the core members. I mean, I count 16, but definitely there's overlap. Some of them belong to more than one focus area. And there were about 30 international collaborators in these papers. By the way, when I say 16 core members and 32 publications, some of them have more than 2 papers each. I mean, we collaborate widely, so many papers have more than one of these authors. Including, of course, postdocs, but also the core members. There appear more than one paper. So there are about 10 postdocs. I think there are about 2 or 3 that I'm aware of that were NITheCS supported directly. The ambiguity is because I think one of them finished in November and another one. So I'm not sure if I should count them as a full year or half year. So there are about 6 NRF supported students through all aspects of NRF, including Sarchi chairs. And 13 students, but there's many more, at least twice these numbers, I would say. I don't know the precise numbers, who are not supported through the NRF by any means, but without the sources. And we organized 4 face-to-face events in 2025, and there's 2 already in 2026 that I will quickly flash. All right, but let me flash a few papers just to see what we've been doing. I'm not sure how I'm doing with time. Maybe I need to speed up, but 10 minutes, okay. 5 minutes for questions. Yeah, okay, so okay, let me flash a few papers. Okay, so I just put 1 paper roughly per work package, so there are about 10, 12 papers. But one of the big things that everybody's excited about these days is this mechanism of fortuity, which is a new way of understanding the microstates of black holes. And there's many approaches to understanding it from some holographic way, using gauge theory understanding. So Jaco was, maybe he'll also mention this, but he was involved in this paper. but there's other papers. So Gary at UJ also had something related to fortuity, and it's all about trace relations between matrices which are not at large n. We're used to taking our matrices to be infinitely big, but now this is what happens when your matrices are becoming smaller. One thing that people talk about a lot also is this SYK model. So this is the quantum gravity in the lab story. So this is where it's a model which holographically seems to be related very strongly to the behavior of black holes. And but it's a very simple kind of spin chain model, and you can even think of simulating it on a quantum device. So this is something that is quite an exciting aspect in our focus area. Palab also had something related to this. You can ask him; he's at the back. If you want to know more about what zeta functions have to do with black holes and entropy. So here is Sajid from UCT discussing complexity. So complexity is also another modern topic that everybody's trying to get some handle on and what it implies. And in particular, let's say in this paper, the goal is to understand quantum chaos. So it's part of using complexity as an indicator of quantum chaos. Again, Jaco is the expert here, so you can talk to him, or he might describe this a bit more. There is some large N techniques that Joao. This is an unusual paper because most of our papers, as I said, are in collaboration. So this is one of the few, perhaps, single author papers that I will be describing. This paper also is, okay, that's me. So this is the exact results. And okay, I had something to say about what we did, but I think due to time I will skip it. You can ask me, but roughly it all has to do with these kinds of nice pictures called quivers, which have a very interesting categorical description. And you can define some interesting, what we call algebroids that basically enhance your usual Lie groups and Lie algebras to a groupoid version, which turns out to be extremely useful in understanding the properties of these theories. There is, okay, more exact results with indices. I want to focus on this paper very quickly because it's an example of a cross-university collaboration. So this is something between UP and WITS, which is a new one for me at least, because, and I think it is definitely helped by this focus areas somehow coming together that we started this collaboration. So, okay, maybe I'll have to go through some of these a bit quickly. So this is Vishnu, which is studying this landscape of Calabi-Yaos and trying to use machine learning techniques. So maybe let's say from the abstract, they have developed a Python library. Maybe this is too small to read, but in order to understand, and it uses machine learning in a very important way, to be able to understand some class of string compactification. So what are the manifolds that are most relevant for phenomenological applications? And because there's a huge number of them, it's a very good problem to apply data-driven techniques to. And that's what Vishnu has been doing a lot recently. More QCD, like this is now going to actual real life QCD. This is Will and his student from UCT. Then there is Isabel, who's at WITS, who has been studying heavy ion physics, but not so heavy. So this is the case, which is actually a new experiment at CERN, where instead of colliding lead with lead, now they're colliding oxygen with oxygen, which is a much smaller type of nucleus. And then you run into finite size effects that you did not have with lead on lead. And that's precisely what they are trying to model here. So think of the finite size aspect. Alan at UJ has been involved. Okay, he has many other papers, but I just found this one interesting because this is about the future. So this is part of these white papers that CERN has commissioned to discuss what is coming next after the LHC. And this is the proposal for the future circular collider, which is going to be up to 100 TeV energies, which, okay, I'm not sure if it'll ever be built, but it will be really nice if these initial studies lead to something like that eventually becoming a reality. All right, so I'm done with the papers, and I can kind of quickly get to the end because I think my time is up. But I just want to maybe say that, okay, we are doing our best to train students and also through SADAX, which we are very happy about. I think it's a very good avenue to provide high-level education and courses to students that we could not do individually. There's 3 courses that I see for this year that by members of our focus area. And I just want to say that it has already led to some interesting cross-university collaborations. My master's student, Jared, took Will's course a couple of years ago, and through that introduction to quantum field theory, they ended up collaborating, and now this paper is going to appear next week on the archive with Will. So again, it's now we're getting also some collaborations between the Gauteng and the UCT nodes, which I think is also nice. All right, so we organized a few other schools. I'll go through them quickly. So this was our flagship school is the Mandelstam School, which happens every January. This was in the beginning of 2025. We had a Joburg school in December that happened at WITS. Then we had a Joburg workshop, which happened at the WITS rural facility, and that's close to Kruger Park. All these were generously supported by NITheCS, of course, and we are very grateful. They were very interesting schools with lots of international participants and good avenues for our students. And okay, maybe just going a little bit to 2026, just last month we had the Engelbrecht and Mandelstam Joint School just here in this room, which was also very exciting. And there was also a quark-gluon plasma workshop organized by Isabel Kolbe from WITS, but at UCT just last month. All right, so we had some outreach events, like a colloquium by Will. We had here at NITheCS in July at the NILC, we had 2 events related to the 100 years of quantum mechanics by Will and by Kevin Goldstein. Isabel, so at Pretoria, some students have an initiative called Physics and Funk, which is a way of providing, just lectures on physics or related topics to a broad audience. So Isabel came and talked about the quark-gluon plasma and heavy ions. Okay, leveraging of funds, maybe don't have to say much about this, but we can come back to it if there's a question. What are we planning? There should be a workshop, perhaps. I was just talking to Francesco. I guess we're waiting to see how the money situation is before we decide where and when. But we're definitely planning a school of mathematical physics. That used to be the Joburg School on String Theory, but we are thinking that we should widen the scope a little bit, make it more, just not string theory necessarily, but maybe more wider mathematical physics topics. And so that's why we're trying to rebrand it a little bit. Then there'll be the workshop on string theory, probably at the rural facility, another Mandelstam school. And we are hoping to all continue a very interesting type of meetings that we had with the Indian community. So 2 years ago, a large chunk of the Indian community came to Kruger Park for a meeting organized by Vishnu. And now the idea is that we're supposed to reciprocate and all go to India for a meeting. I'm not sure where the funding is going to come from that, but we are hoping that it can be made to work out. Okay, challenges, maybe I should say a couple of things. Okay, so representation definitely in terms of diversity at the high levels is not ideal. Definitely in terms of our students, it's quite a nice and varied bunch of students, but somehow as one goes to senior levels, as you could see also from the focus area core members, there isn't that much diversity. It's also very centered in Gauteng, which we need to change eventually. My problem often is that our students tend to, given the 3-year PhD kind of story, they have to be very, detailed focused in order to make it in time. And that means they lack the breadth that will eventually, be useful for them for their academic careers. And we need to change that. And one good case can be made to have a taught master's program in theoretical physics. So I think WITS has already done had some discussions or even planning like more concrete things to introduce something like this, just to give them a little bit more background, just not on their specific focus projects, but something more general. Isolation, yes, our students do not, even though we bring international people, our students don't get to travel very much abroad, spend time in other institutions. I think this is something where we could make better use of bilateral agreements that exist. So in the past, and maybe it's still valid today, maybe Francesco can tell us, but you had an agreement with ICTP, I think, in Trieste, and through that, some students could go and spend like 3 months there, and that was very useful. I know. So this is a criticism of us, like we're not of you. I mean, we need to be more active in using these agreements and sending our students abroad. And finally, okay, retention is an issue. I mean, we do train a lot of students. How many of those students end up getting an academic position in South Africa, and ideally perhaps in one of the non-core universities? That there are very few so far. So that's something that would have to change. And I'm not sure how, I'm not the right person maybe, but definitely I would say something like more starting grants that people can apply for and then be guaranteed a job if they get the grant. These kinds of things could perhaps help to get these people beyond the postdoc phase and get them into the academic system. All right, so we are all kind of active. We're producing outputs. We have made progress in this in the past year, and we are definitely attracting lots of postdocs. The students are strongly involved, but there is more to be done. And I'm also looking forward to hearing what other people are doing and how they are approaching the problems that we are all facing. And thanks a lot to NITheCS for all the support.
Maybe some quick questions and comments because we're already running out of time and we don't have much coffee breaks to go. Yes, Inga, please.
I think what you said there with the 3-year PhD is really interesting because you don't do a coursework master's, and I don't think I realized that before because in statistics, not all of them, but a lot of our departments across the country have a coursework master's because obviously statisticians go into industry and it's a little bit of a professional arm and an academic arm. And I must say our PhD students on the whole will finish in 3. I haven't found it as a challenge. So it was really interesting that you said that.
I mean, they finish, but are they independent researchers when they finish?
Yeah. So ours finish and become academics in the 3 years.
Okay.
So I think what you're saying is really.
But that's because you had the masters before. They had a taught masters.
Masters, exactly. Yeah. So I think you're exactly right, and I think that's.
Yeah, we don't have that in our field. There's not that many.
Yeah, it's because the government wants us to do research masters. There's more money, so that idea has to flip. That the coursework masters is better in science. Yeah,
I fully agree with that.
That was a really interesting point that you made there.
Please, maybe one. Okay, 2 more questions, quick ones.
So this MITP have a proposal of coursework masters, right?
Yes, I saw it. Kevin shared it with me. Yeah, that's why I mentioned it. That we are trying to fix it. Whether how well it will work, it's still the early stages.
I don't know. Sorry. Just quick comment. So I don't know how this bureaucracy works, but can we have a multi-university coursework masters or not?
Coursework, yeah, that's something.
I mean, SATACS is trying to fill that gap.
That's what we try to do. Yeah, we started with SATACS and the battle, and we have already discussion with the STI, the AGT, is to give credits on that. Yeah. And the problem is every university has a different system. So there needs to be a kind of a DHT guideline that says if NITheCS awards credits, the university acknowledge them. And at the moment it's not like that. Some universities in the SATACS courses play clever and they have in the handbook honors courses that are kind of jokers, and they say the students are registered for that and they give them the credits. Other universities don't have it and the students just do it for fun. Yeah, but that's a battle that we are really aware of, and it would be really good to have these taught masters national, in particular in disciplines that are scarce skills. Yeah. And all of our disciplines are in that category. Yeah, so that's a battle that we started fighting, and hopefully we will win before it's too late. Yeah. Sorry, your question, and then we finish because otherwise.
So you spoke about these wonderful schools and workshops that I suppose funded through this project.
Yes.
And is that sort of the basis of how you're trying to unify the different strands of research in your
definitely that's a way for all of us to talk. Yes. Yeah. I mean, especially also the focus area workshop, because there is this division between the more formal parts of our focus area and the more phenomenological, like more looking at experiments people, and we would probably not end up in the same workshop because there was a quark-low plasma workshop and there was a string theory workshop, and these are different. But in the focus area workshop that we had here, we actually got to talk to everybody, and that's how we got.
So that you'll be the benefit.
So I think the focus area workshop was useful to have that as well. Yes. So, but we don't have a common event technically as a school for all the students.
Any ideas for how to go beyond? You emphasize the bits heavy sort of component of work. Any ideas to expand?
Well, we cannot. The thing is, we cannot invent people who are not there, right? So if people are not hired by other universities, I think we've covered the universities where people do things related to our fields. If we haven't, then we'd very gladly, accept them into the focus area, I think. So that's why I'm saying I think there needs to be some avenue for maybe our students or people who, are trained in similar topics to, get jobs at universities that are not Gauteng based necessarily. I'm not sure what that avenue really is. I know students who are struggling, who have a publication output, but they are not really able to, you'd expect that they would be able to get a junior lectureship somewhere among the 27 or I don't know how many universities there are. 26. Okay, but they are struggling, and I think maybe there needs to be some funding instrument that gives them an extra boost at that stage in their careers to say, well, look, apply for it, and you're guaranteed 3 years of salary, and but then the university has to hire you, and once that your whatever probation is over, maybe there are some things like that. But definitely abroad, I know many of these grants. Yeah, so that could be one way, but it's kind of goes beyond us. I mean, we do our best to train the students. We do our best to work with the postdocs when the students become postdocs. What happens after that? I mean, there's only
we need to find a way to get the HDIs and the not top 5 university involved in all these.
Yes. Because we're only really 4 universities somehow effectively, and how many people can be hired? I mean, there have been good hires. There are postdocs that were eventually hired. Isabel is a great example of somebody who did her honors at UP, her master's and PhD at UCT, went abroad for postdocs. Now she's at WITS. So there are good examples, but I think it's almost a drop in the ocean. I mean, we need
Maybe
many
we can
more.
discuss it at the end if we have time. Okay,
Thank you.
Speaker is Pedro Montero, speaking for the Earth Systems Modeling Change Modelers, and he will give his talk online. Pedro, can you stop this presentation here? Pedro, say
Yeah, stop talking when I got you. More than 30 minutes to find something.
So that, then, let's see who's supposed to speak after Pedro. Catherine, would you mind? Now you have a little more time. I don't know, something, he just sent a message and. Your switch is off. Yeah, here you go. Thank you very much. All of us. I'm trying to find out what happened to play.
Here we go. Right, can everybody hear me? Yeah. Right, good morning, everyone. I am. Hallelujah. Good morning, everyone. I'm Catharine Esterhuysen. I'm here representing the focus group on computational modeling of functional materials, and with our focus being to drive sustainable innovation. There we go. So the here we go. Oops. So the idea of this particular focus area is that we are trying to use the computational methods that are obviously the focus of NITheCS, particularly using machine learning techniques to accelerate the discovery and design of functional materials. And and obviously there are many different kinds of functional materials, and we have decided to specifically focus on energy, space, and gas sensing materials, just to, as an initial starting point, as the group is still fairly small. So when I say the team, or at least the group, the team is these people at the moment. So we have a principle in the focus area that we have a rotating coordinator. So Regina was the coordinator last year. I was the deputy. So this year I've taken over as the main coordinator, and Edward Mapasha is then going to be our new deputy coordinator, and then he will obviously take over next year. So in addition, we have Krishna from UJ, Chad from UP, Eric from Venda, Kingsley from UKZN, Raji from UNISA, Lyndall from NWU, David from Central University of Technology, and Yekin also at UKZN. And we are busy looking into three new associates. So we are busy looking at CVs and ensuring that they are suitable new associates, and then we will be nominating them. And so at the moment we're looking at somebody from UCT, somebody from Univenda, and then somebody from the Sefako Makato Health Science University as additional associates. So how we've divided our focus area up is into 5 different work packages. The first one, which is headed by Anieken, and you can see myself and Chart are on the are also members of this particular work package. And as you can see, that the aim here is to try and develop models for functional materials. So we're looking at 4 interconnected areas: modeling of materials and property characterization, understanding process phase diagrams, and then optimizing the rational design principles in order to kind of prepare. So this is the basic work package to try and understand better what one needs to know, how one can then utilize fundamental principles of or fundamental properties of materials in order to then help design new materials. So it's been it was a bit of a tough year, but we did get through a literature review, and we've done some planning, but we had a lot of challenges. In fact, this is a common theme through most of the work packages, is that there were challenges of finding dedicated people to actually take on the work. So we really struggled to appoint research assistants and so on. There were a variety of different reasons for this. Well, I'll go into those a little bit later, but we identified suitable people, but then really struggled with bureaucracy to actually get them appointed, also due to delays in releasing funds and so on. So our second, oops, I keep hitting this too fast. Our second work package is in machine learning for designing novel functional materials. You can see that this is a very important package in the focus area. Most of us are involved. And the aim then is to take the stuff that we now learned in work package 1, combine those first principle calculations using statistical inference, and then obviously also incorporating experimental data, into trying to put together a single AI-driven development of novel materials. So discovering, using a discovery framework for developing novel materials. So this has gone much better. There was a lot of focus on the DFT aspect of the process, and this resulted in a number of publications. I'll list the publications a little later. And there were also elements of the framework that's driven by AI. Was then the colleagues there started to put everything together. They did an extensive literature review, and then obviously also a deep analysis of the machine learning codes, and started to actually make progress in this. Again, as with work package 1, they weren't able to get a person to work on the project. There were problems with the releases of funds, and again, bureaucratic bottlenecks at the home institutions, the way the nodes are releasing funds to different institutions was identified as a challenge in this particular work package. The third work package, this work package, as you can see, is headed by Raji and Regina. The work package 3 is headed by Kingsley and Eric, and again, quite an important package in the focus area. A number of us, or most of us, are also involved in this, and the particular focus on this is to design functional materials for energy applications. So particularly to design and discover next generation batteries and catalytic materials for hydrogen production and storage. So again, looking at catalytic performance and materials, porous materials and gas sensing materials as well, being part of this. So again, the DFT framework, we were able to use that to produce several peer-reviewed publications. And then there's also been some complementary investigations. So what was done in the DFT then was used to understand and develop some emerging functional materials. As before, the pace was slowed by the fact that we couldn't find a dedicated researcher, and there were delays in releasing funding, and again, particularly institutional bottlenecks. I think of all of the work packages, this has been the one that's been the most successful in the last year, headed by Lyndall at Northwest University. And what they've been focusing on is specifically space materials that are suitable for radiation shielding and have durability in low Earth orbit environments. So they've put together a very good set of collaborative research activities. I think this has partly been helped by the fact that Kingsley moved from Northwest University to UKZN. So he and Lyndall and Anieken are working together very closely, and I think this has really helped. So this very close collaboration has really helped in pushing this particular work package forward. So they've been able to consolidate those collaborative research activities. They've decided on the materials to work with. They've developed modeling workflows. They've started integrating the different methods, so the DFT, molecular dynamics, and so on. And they've started aligning everything through the collaborating institutions in order to start developing future postgraduate and postdoctoral research. And I think a very exciting part of this is the fact that they hosted, Lyndall and Kingsley hosted a machine learning workshop specifically focused on materials. And this they felt fostered new collaborative links within the community. So this is something that we aim to do more. This has very clearly come out of what we've seen is that these workshops are really important. So I will mention that a little bit later. And again, they had challenges, particularly again with staffing and being able to appoint people. And this was actually particularly that they found that it was the difference in different institutions and how they managed the appointment process that was challenging. And this is the type of administrative bottlenecks that we have been experiencing. So work package 5 is the last of our work packages. This is particularly looking at functional soft materials. So particularly functional polymers and biological materials for applications in plant and human health, and particularly looking at developing environmentally friendly materials. And then there's some basics in there in trying to understand structure-function relationships of the soft materials, and then to try and develop a bottom-up approach of how to design these materials based on this fundamental knowledge. They did not identify so many challenges or any challenges, but they did have a lot of good success. There was progress in calculating the properties of a range of biological light harvesting molecules from cyanobacteria and other organic molecules, specifically for solar cell applications. And they were able to study a whole bunch of materials to predict their spectra and molecular parameters. They were particularly looking at molecular aggregates for this, and then using neural network models to try and describe what is happening there. And so they were able to publish well in this particular aspect. So so this has also been work package 4 and work package 5 have really been very successful in the last year. So we've had, as part of that, we've had a number of success stories in addition to the publications. I'll talk about this a little bit later. So obviously there were publications and presentations. I'll also talk about that. So Kingsley actually won a prize for a presentation that he gave on NITheCS funded work at a conference in Ethiopia. So that was very exciting. On the basis of the fact that there was a project being funded by NITheCS, the PhD student who was appointed just for 3 months as a research assistant they were then able to convince their home institution, so UKZN, to fund the PhD student to go and visit an international collaborator. So that's been very successful. And then although we didn't specifically organize it, Krishna Govender was involved in the NITheCS CHPC summer school, which our previous speaker mentioned, and they also felt that this was a very positive initiative. And again, this, as I said earlier, this highlighted to us that we really, schools and things like that really drive the collaborative work that we're doing within the focus area, and we want to do more of that. So there were lots of outputs, as you can see, lots and lots of publications by all the members of the team. In terms of additional outputs, obviously there were conference presentations. So between the invited and oral presentations, there were 22. We had a lot of science engagement, so there were public lectures and so on. So we organized 2 workshops. One I've already mentioned, which was at NWU, organized by Professor Obodo and Professor Square on machine learning for materials. And then we also organized here, or I organized here at Stellenbosch, a crystallography workshop focusing on the calculations involved using crystallographic software. And then we had a number of students that were trained as part of the human capacity development. There were 2 directly supported students, not through bursaries, but through short 3-month appointments. So there was 1 student and 1 postdoc, and then 11 indirectly supported students and postdocs who were helped through a variety of different means to continue with their studies. So we had a meeting this week about our strategic plans, and one thing that came up very clearly is that we need to strengthen our collaborations. Where we've seen the success has been in our work packages is when there's been strong collaboration between the members of the team. So we want to then have, as a result, to support this, we want to have an in-person collaborative meeting. We were trying to organize it for January, but that unfortunately didn't happen. So it's now going to happen in July, when the academic responsibilities are a little bit easier. But we realized that we need to have a meeting before that. So we're going to have an online collaborative meeting sometime before the end of March to try and really focus in on how can we work together better. Part of that, we want to then have exchange visits between the PIs, but then also between students. And we particularly want to focus on sharing research assistants and postdocs. So the problem with appointing postdocs and research assistants is something that really is going to need to be addressed, because obviously we want to have these joint assistants. And then the other thing that's come out very clearly is that we need to have joint workshops. We need to have joint workshops with PIs presenting together and also then attending. So the idea is that we would have a couple of joint workshops through the year, and we'll discuss what these will look like at our online collaborative meeting, but that all of us should try and attend all of those so that we can learn together. And because one thing that has been picked up is that collaboration improves when we all go attend a workshop together. I mean, it's like sitting here, right? So that's what our plans are for the year. And then we have as you see, we've had some challenges. So we have some suggestions for NITheCS, sorry. So I hope that some of the challenges that we have this year can be solved. So the main challenge that we had was the appointment of the research assistants, because different universities had different policies with regard to how the research assistants are appointed. There were, which then made it very complicated, very difficult. So the process, so we wanted to appoint some postdocs, it's not postdocs, some research assistants just for 3 months. One was a postdoc, one was a PhD, but it took almost 6 months to appoint that person by the time everything had gone backward and forward, and between the nodes and NITheCS and the home institution and so on. So, you know, it was much, much longer to actually get the person there than they were actually able to be paid for. So our suggestion with this is that the appointments actually be handled by the NITheCS office if possible. This would then enable the students to move around. As we said, what we want to do is we want to share students. So if we could have the students appointed by NITheCS, then we would be able to place them anywhere and we could move them around. So that would be very helpful. If that's not possible, then at least if we could get NITheCS to help us sort of negotiate with the nodes in terms of how we get people appointed, so that we don't have to, if there's a very long and bureaucratic process to appoint somebody, could you kind of go, well, you know, is it possible to kind of sidestep that, not because we want to not do the thing properly, but because we want to get work done, right? Particularly for those short-term things. We also found that the way the funding is passing through the nodes is problematic. Very often, unfortunately, there were slow response times from NITheCS. So we had people who were supposed to come and give talks who couldn't get funding because every time we tried to get feedback from the NITheCS office, we had to poke multiple times and so on. So it would really be wonderful if we could, sorry, something, I don't know. I think this is, I've copied the wrong version of this because this looks, something that's happened, weirdness here. What we want, what would be great is if we could improve the communication. Yeah, there's definitely weirdness happening here. We've also had challenges with communications, and we think some of it has to do with the fact that not all of our members have NITheCS email addresses. So it would be great if all of the associates could have NITheCS email addresses, and also then that we could get feedback. So some of our associates, we nominated them, and we were told that they would be accepted as associates, but they haven't had any feedback from NITheCS. So that's also being problematic in terms of the communication. So it would be great if all of the associates have their email addresses and could be included on the communication. Yeah, and as I say, we've had challenges with feedback. So, you know, things only happen after we poke a number of times. They have improved, but I think everybody was finding it challenging at the beginning of the year, at the beginning of last year, to find the methods to follow, or the protocols to follow. And that's it. So that was all I wanted to say, except for there was a lot of complaining on the last slide. But actually, we are incredibly grateful to NITheCS. We have been able to do stuff that we wouldn't have done, and we've been able to forge these collaborations, as the previous speaker mentioned. We've been able to forge collaborations through meeting people under the NITheCS headline that has allowed us to form collaborations, and it's been incredibly powerful from that perspective. So we are very grateful to NITheCS, and we are looking forward to improved improved admin and so on this year, and that everything goes fantastically well. So we're very grateful. Thank you.
Now we have plenty of time for questions.
Yes,
And then I will reply to.
In spite of the complaints, you've really forged a very nice and so on.
Yes.
For I suppose many of the kind of computational and theoretical perspectives into this underpinning, and especially strongly, I suppose, in materials that you need data for your machine learning models from people who synthesize these materials, plus they need to volunteer to synthesize the ones you bottom up predict. How is that developing, and how does that fit into the context of this research approach?
So that's a very good question. So we've spoken about this before in terms of how we can do this, and the principle at the moment is that we kind of have our own networks. We've actually wondered about maybe in a future sort of iteration of this particular focus area, whether we should start including experimentalists as well. But at the moment, we're kind of just working with our own networks to gain that experimental data. One of the things that has happened is that Krishna's come in. Krishna he's like me. He's a chemist, not a physicist. So most of the people on the team are physicists, but Krishna is a chemist as well. So he also has a network. And then one of the people that we're looking at bringing in as a further associate is also a chemist. So hopefully those networks will help with actually getting the experimental data. But yes, that's something that we need to really consider in the future.
You mentioned a few times that density functional theory computation was related to machine learning. is the ambition as great as in the general protocol that you can put on some repository somewhere for people to access publicly, or is that not really the
So there's certainly that is one of the things that is particularly with respect to work package 2, which is the machine learning. That's one of their specific aims is actually to have developed something that will be more widely available. So I'm guessing through something like GitHub or something.
Yeah. More questions or comments? Sorry.
Thank you very much. I just want to add to what you have raised on the challenges. It's not only your focus area, but most of the focus area. The challenges that you have is the issue of moving money from University A to University B, different cost centers, and also the difference of policies, the appointment of the research assistant. This is some of the things that most of the focus area we are struggling with. I don't know if it will be possible to centralize the appointment and then you just send the research assistant to the institutions. Maybe in that case, it will shorten the delay and also the challenges of the policies. Thank you.
Okay, let me start. The reply to the complaint. Yeah, was complaints.
Just curious about when we want to appoint a research assistant in the focus area, how is it decided where they should sit other than the university on a rotational basis?
So we had an online meeting where we discussed who was most needed a researcher. So but most of the work packages wanted to appoint a researcher, and you can see some of them have just smaller groups and other. Yeah, but none of them are localized geographically. Yeah, so we basically discussed who would be most using that person, and we decided to base them there. But the idea was that person would be involved with all, and it would have been what we wanted was actually people to move around. So to go and visit, or at least have the PIs visit them. So to talk about what we wanted them to do in the context of the whole work package, and not just the supervisor.
Okay, let me start. And please remind me, I forgot about complaints. First of all, the administrative processes. Last year, we started operating according to the legal document that binds us all, which is the consortium agreement. Yeah, and funds have to flow from the hub to the nodes, from the nodes to the branches. Yeah, that's what auditors and legal functions also.
You can't change that.
You know, at the beginning, it was low because some nodes and branch didn't even have a cost center. So it was not even. I think the microphone there should pick it up. Okay, but I'm happy to use it. So if there is not even a cost center, there is nothing you can do. Yeah. Now I think all universities have a cost center, and there is just one university that hasn't signed yet the consortium agreement, yeah, which I won't mention, not to blame UNISA. Yeah, yeah. So we are almost there. Yeah. So and then hopefully that will work. Yeah, because we are also finalizing the formal appointment of the heads of all the branches. And then again, it's a slow process because we don't have authority on the HR departments of the universities. NITheCS essentially has 5 full-time appointments, and they're all here. Yeah, it's me, Rene, who runs the operations, Nelly, who runs the research programs and all the government things, Therese, that does the finances, and Bali, that organizes our workshops, yeah, and runs essentially the office here. That's all we have, yeah. So if you don't reply me for an email, I can show you my inbox, and Rina can show you your inbox. Yeah? We're just overflowing. Yeah, you know, we are expected to run a big operation, but we don't have a big staff to do it. Yeah, it's good. We want to keep it lean. Yeah. you mentioned that we are improving, yeah, but that's because we make use of AI wherever we can, yeah, yeah. That's the only chance that we have, yeah. That's what, and you know, and AI is getting better. We are getting better at using it, and less things fall through the cracks. Yeah? But if things fall through the crack, just send us another email, and you're at the top of the inbox. And if you're in Stellenbosch, just come for coffee and let us know. Yeah. Yeah. It's not difficult to find us. Yeah. So that's the one. Yeah. The other big complaint is the research assistants. Yeah? I assume research assistants are students that you give. Yeah. And if they're students at one university. So we can only pay them to the university where they are students. Otherwise, they have to become Stellenbosch employees. Yeah. And please don't give us that additional job because that implies job descriptions, advertising, interviews. It will never end. Yeah. So if our students, give them a top-up bursary at the university where they are, and use mobility funds to send them back and forth. Yeah.
So would that be possible? I mean, because at the moment we've been told we have to appoint them. So then it's an appointment process, which you have to advertise and you have to do, you know, all of you have to jump through.
You know, we don't even have those positions in the business plan.
So, I mean, would it be?
We have bursary programs, yeah, we have internship programs, and we can give you, if you want to use.
We have to appoint them. Would it be
but
possible?
Not by us.
No, I realize that, but would it be possible just to have, instead of appointing them, to have some kind of just ad hoc payment? Because that at least then we wouldn't have to go through.
Give them a
that's
what Francesco's saying. You give them a bursary as part of the grant.
Yeah.
We transfer it to students.
No, bursary, you know, bursaries are, because of how NITheCS was born, are administered by NRF.
Yes,
yeah.
Exactly.
And we are fighting the battle with NRF to align the bursaries to the research program. Because at the moment it's just random. Yeah? We don't have control about anything.
I think like partial funding.
Yeah, no, but you can give a top up to a student. Yes. Nobody can stop you to do that. So yeah, but that you can only do, in your case, to a student that is registered at Stellenbosch. Yeah, if the student is at UK's 10.
But we could then call it a top-up bursary.
Yeah,
we're appointing.
That's but full bursaries.
Yeah.
Out of the budget that you have access to, you can't give.
Okay.
Yeah. Because those are administered by NRF. Yeah.
If it's an NRF grant, you are not allowed to use grant for top up anymore.
Really?
Yeah, because the NRF has uplifted the bursary level and fellowship level. So as a
but how do we pay students that do tutoring jobs?
If the student doesn't have an NRF bursary already, then you can. So if they have a full NRF bursary, sure, but these might be students who are not funded.
Yeah, but if the student is on the current level, including postdoc and the postgraduates, if they are funded at the new level.
On which new level?
So if they're not,
if they have a full NRF bursary, yeah, but if it's some other, then the student is sorted. Yeah, you don't need to pay him to do what he has to do. Yeah. But it's very difficult for us to appoint resource assistants at 300, at 26, 27 university. That's
if it's not
technically possible, but then we don't do anything else.
Ad hoc payments, there are researchers, people with MSc.
Yeah. For instance, the student that do tutoring, you can pay them in that way for.
Because for a bursary and top up, you have to sign that they can't use any work. This is not compensation for any work, so they have to keep that.
So the ad hoc payments.
Yeah,
I'm not sure whether that is possible through the other institutions. It's Stellenbosch, but I'll have to find out.
I think it should be possible at all institutions, because at all institutions there are students that tutor and do things like that, and they are paid for it.
3 months.
Yeah.
Just I was just saying that is possible if you do it like a top up. You can still go to other university as a top up, and then you call it a top up funding. or like a bursary. Yeah, that's always possible.
Kevin, you had that, raised your hand.
Yeah, so I'm going to wear my other hat as just an associate of the KZN work package, which is part of the bigger work package. So now I'm here representing. We're having immense problems exactly the same. But I just want to try and be clear. So first we didn't get money, and I'm gathering now probably because UKZN didn't have a cost center. So nobody told me that. But anyway,
You know, you could
everybody's very frustrated
invoice
because we
us
didn't
and
get
so
the
on and
money.
so forth. Yeah, yeah.
So, but now we just got the money for last year. Now, nobody seems to answer this question at UKZN. Do we now have to spend it by the end of March because it's last year's money, or can we roll it over?
No, you can't roll it over.
Can't roll
You
it
have to spend it.
Well, they're assuming we can. So I've got to take
No,
that
but
message
then I
back.
speak to your head of nodes.
Yes. And then the other thing is about this. We're desperate to use some of this money for a research assistant.
Yeah.
I just want to be clear.
Look,
You've got nothing against it as NITheCS, except within whatever rules of NRF and the university.
yeah.
Because I've been told that, I'm not going to say by who, that NITheCS says no.
No, you can't use the money that we give you for a full bursary and to appoint postdocs, because those are other budget items and there are other processes for that.
Let's say
yeah?
a student did not have a bursary with the NRF. Could we use the funds for a bursary and
No.
then they do this project?
No, you can employ him as a research assistant and give him something, yeah? But formally, you can't give him a bursary.
We
Because
can employ him
NRF
as a
is gonna-
research assistant for this particular work.
Yeah, not the full bursary.
Okay, but it's not even enough for a full bursary.
No, maybe partial funding.
Yes.
Yeah,
Okay.
You know, there are 27 universities in the system with 27 different rules. You need to play your system. Yeah.
Yeah. But find out who knows how to.
But formally, you
Anyway.
can't give them the bursary and you can't appoint postdocs because those are other budget items and there are other.
Can employ an ad hoc, partial.
Yeah. If you give a student 10,000 rand to do something, yeah, that you can do. Yeah.
We have a quick
Please.
question. So the students were not funded in,
Yeah.
let's say, wait something. They often demand one thing or ask for one thing, that we pay their university fee. They don't have to pay,
Yeah.
won't have to give them any money, but just pay university fee, which is about 30 to 40,000 rand.
Yeah.
So can we use this focus area money for that?
I don't know.
I think rather than paying them fees, rather than maybe pay their student from their student account.
Yeah, but that's what he's saying. So you pay just the fee amount into there.
Yeah, and then the student pays the fees.
Okay,
Yeah.
we can do
Or
that.
get the access.
Or get the access.
But you mentioned 1,000. Is there some kind of limit? What's allowed?
There is no
So in my
technical
experience-
limit. It's just common sense that
Yeah.
you can't give me the full burst. Yeah, so don't give me that amount. Yeah, and also you don't want to because otherwise you have money to do anything else. Yeah.
Okay.
Our faculty accountants, as I've got money like what you're saying before with another grant, and I couldn't put more than what was owed on the account because it's not an NRF bursary. NRF bursary will sit there as a positive. But if they have 25,000 rand fees, I can only put 25,000.
Yeah.
So I think that might be your limit. It might be on the student's account.
Look, otherwise it becomes a bursary and that you can't give him, yeah, or her. Yeah. We all try to be as creative as we can within the limits of what we can do. Yeah, and every university has different systems, HR procedure, this. That's in your hands. Just speak to your head of nodes, head of branches. That it's their job to facilitate that. Yeah. If we can help, we help, but we can't appoint someone at UJ or at UKZN. Just can't. And appointing someone here and send him to UJ or to UKZN, that's a nightmare. Yeah? Because you can imagine that there's a bureaucracy involved. Any other complaints?
It's not the complaint. I just want to ask, because I managed to get my funding and spend it at UKZN. Of course, yes, that takes, the persistent, check-in with Lila, who's a new NITheCS admin person but the money was there, and afterwards I managed to spend it, including the assistantships.
No, then we need to talk.
Yes.
Because I'm in a different package to you, even though your colleague is my leader, but he doesn't seem to understand this.
No, one of the
Because
best.
we're on the record, I'm not going to comment anything.
No, I can comment. One of the battles that I'm fighting, and I invited all the head of nodes to this meeting, but I don't see many. Their job is exactly to engage with you guys locally, because there's only, I don't know what challenges you have there, So their job is to engage with you and facilitate this, They're there to help you, They're the conduit to solve the problems there, Go and knock at their doors, and tell them, where is my money, I can't do that because I don't have control to the cost. Once the money leaves Stellenbosch, it's not not my problem anymore. It is my problem, but I can't solve it, So, when we designed NITheCS, there were different possible models, But the model that we chose was really to make it as complicated as possible. In the sense that we didn't want the research to be localized, because otherwise maybe material simulation was in Stellenbosch and nowhere else. We wanted research to be distributed as inclusive as possible, and training and so on and so forth. But the money needs to flow in some structured way. And we had 26 legal departments involved, and it was agreed that the monies flow from the hub to the nodes, from the nodes to the branch, because that makes it easier to audit it. At the moment we have the audit, and we are audited, but in our audit, the nodes audits come in from next year. In the node audits, the branch audits will flow in. But if we had to do 27 audits flowing into Stellenbosch, it would take 10 years to do an audit. Already with 5 nodes, it's difficult, because there are still some outstanding financial statements of some of the nodes. And I won't name them because I don't want to blame UCT. So please help us, because otherwise we are in trouble. And the reason for this, delocalizing the research and sort of centralizing the money, is that so people have to speak to each other. We wanted the nodes to speak to the research program to speak to the nodes, to the branches, and to the hubs, so that we interact as much as possible. Because without proper communication, it will never work. So the need for communication is built in. You mentioned email address. Everybody has a NITheCS email address. People just don't use them. If they look in their inbox, they will find the invitation to accept it. If people want it, just tell us who needs it, and we send them the password again.
Is that why I couldn't sign on that?
Yes, because
I'm just trying to use my UKZN.
No. In order to fill form, nominate associates, and please do it now. The call is out to nominate associates. But to fill out the form, you need to log in with the NITheCS email address. It's also basic security.
But speaking of nomination of associates, does the associate, if the associate is a well-established expert in the field, but the associates don't have a PhD because it's not a requirement of the field, can that person be an associate? I'm talking about, for example, Anman Pillay.
Someone who works in the industry.
No, I mean, he's at university, but he's in computer science, and you
can nominate. I mean, it's for we have the category associates, and that by requirement we expect people to have a PhD. Otherwise, we have the category emergent associates.
It's not an emergent associate because I mean he's active academic. I mean he's
Yes, but if he doesn't have a PhD,
because it's computer science, you don't have to have a PhD in computer science. You don't have to have a
Universities, you have PhD.
Why?
you know,
In computer science, you must have a PhD.
you know, I'm doing now the exercise for NRF to find out
Must have a PhD.
how many of our associates have an NRF rating. Yeah, and it's not even half. Yeah, yes.
Well, I didn't have a rating last year, but that was because the NRF took a year and a half to send my.
I don't know, but you know, I downloaded the list of rated researchers from their website and I compared it with the list of associates, and roughly half doesn't have a rating. Yeah. And NRF won't be happy. Yeah. So that's another battle that we will have to sort out. You know, we are doing well with publications, but in the eyes of NRF, and they asked explicitly for that. Thanks God there is ChatGPT that compares us automatically. Yeah. But we're not doing great there. Yeah.
Francesco, many NRF rated researchers are very disappointed in the sense that they're hardly getting any funding or no funding at all from the NRF.
I know.
So I'm not sure if this is some contributing factor to, you know, people are not interested in getting.
100%. I know lots of people that don't bother anymore about NRF rating. Yeah. But as long as it is an official policy, technically I have to encourage you to do it. Yeah, privately I can tell you don't do it, but officially I should tell you, please get NRF rated. Yeah. You know, it's not coupled to anything. Yeah, it's just another layer of bureaucracy. Yeah.
Universities often like it.
Sorry?
Universities often like it as well if you're rated.
Yeah, because that's policy, and sometimes you have to show we have so many rated researchers and so on and so forth, and like we do now. So I encourage you to do the NRF rate. Yeah. Did I forget any complaints?
It made me feel terrible.
No, otherwise I think it's the perfect time for the coffee break because we have only 15 minutes, yeah, and there should be coffee outside. And at 12 we can continue, and I don't remember who's speaking at 12. Inga, it's you.
Cool. Right. Okay, so I'm representing the machine learning, statistics, data analytics, computer science focus area. So our official name is Elevating Data Analytics and Machine Learning in South Africa. And our longer description is this one here. It's about advancing capacity in statistics and machine learning through focused and collaborative research initiative. And in one of our group meetings last week, we were pondering about changing our long name, because if you go to the NITheCS website, ours is like the longest name there. Maybe not the longest, but one of the longest ones. So we thinking about just calling ourselves Data Analytics for Science, which is what we are. But that's just something I'm posing to everybody. So I am the lead on this focus area from the Department of Statistics at the University of Victoria. And Priyanka hiding in the back is our deputy. She's from the Department of Statistics and Natural Sciences. Yes, apologies, at Stellenbosch universities. And then we've got a few PIs. So Tian from Northwest University, Marily from Northwest, Sinayskiy is from Stellenbosch University here, Priyanka is obviously also, and myself, and Justin from Stellenbosch University, and Stefan Lotz from Sansa, and also Northwest University. Yes. Okay, so I just put this on from the website just to place everything. I think everyone here in the room knows, but I think we sort of represent the statistics and the data science arms here, not exclusively, obviously, but that's where our main focus is. And this is obviously what we look like on the focus area website. And our link, all our information is there. Officially, for the first time since yesterday, we have been not visible until yesterday. And so that's why I wanted to put it up, just because we're so happy that we're on the website. Okay, so we've got three main pillars in our focus area. It's about advancements in theoretical statistics and machine learning, so very much focusing on the theoretical side. So in our fields, obviously, like all of us in the room, we're focusing on our science as its basic roots. One of our very other big arms is about sustainability in our academic departments. And I will talk a little bit more about that as well. And then the third really, really important arm is about the collaborative effort, which is one of the big things for NITheCS. So it's about how we can collaborate on analytics, the other fields that need analytics skills or analytics support or whatever is needed. So those are our three big things. So the first one is your base research. This is about capacity development, and then this is about the collaboration aspect. Microphones here. Okay, so really don't consider to read all of these, but these are all the people that is involved. So, but what you'll see is it's obviously on the first slide was mostly Stellenbosch and UP and Northwest University, but actually we have huge amounts from all over. And in particular, this group over here has a lot of HDI involvement. And that group as well has a very big network across the whole of the country with all the HDIs involved in it. So that's why I just wanted to throw this slide in there. Okay, so I'm going to first look at the theoretical advancement pillar. So underneath that, we've got these 4 work packages, right? Knowledge discovery and complex sequential data, generalization and deep learning, multi-dimensional visualization, and the last one, analyzing hidden patterns in complex data on different manifolds. So the first one, generalization and deep learning, is run by Marily from Northwest University. And so I'm not going to tell you about, obviously, all the actual theory they do. I want to tell you about all the activities we've held and what our plans are. So they held a boot camp in February 2026, so only a few weeks ago. And they used the NITheCS funding to get everyone there. So people came in person, and you can see quite a nice large group there. So that one of my PhD students was actually there. And that was really successful. She says it was really, the people who came really learned a lot, and it was done really nice. It's not the first time they've held something like this, but this is the first time that was sort of sponsored through the new NITheCS structure. And then they've got a few other things going on. So they've obviously second time, yeah. So really, really nice. So they've also got ongoing collaboration, of course, besides this boot camp. They have many research discussions, they have peer reviews, paper discussions, and they also have a shared Discord server. They're a very, very well-structured research group, very productive. They presented January 26 in Norway. They went to NITheCS, which is one of the big computer science conferences in South Africa. And they've also got a MLR paper under review, and they're planning a writing workshop next. Okay, then the second theoretical work package is knowledge discovering complex sequential data. And these are the active projects that's going on in there. So the first two are fundamental, visualizing feature effects for deep time series models and manifold adversarial training. And then there's a few applied, so very collaborative type of projects. This one has got to do with continuous finger angle estimation. Sounds weird, but robotic arms and things like that. Solar wind coupling, sensor, prey capture event detection, and then they've got a few others that they're busy planning in this in the second quarter of the year. They've got 3 existing members and 2 enrolled master students, and they've got a new international postdoc as well, and they're continually working on a toolkit that will obviously be useful for further sharing and collaboration. Okay, the Mesias group is here at Stellenbosch University, and they leveraged some funding with NGA Mass last year for Marisa and UNA to visit Monash University in Australia. So they are 2 young academics in statistics in South Africa. Yeah, Marisa is at Wits and UNA is here at Stellenbosch University, and they went over there for a research visit. They have, as a result of this collaboration and their continued collaboration with Stellenbosch, they've published 3 R packages: Move Easy, GPA Bin, and Wired Rhino. If you work in R, the cool thing about R is we make cool stickers. So when you make a package, you get to make a sticker. And then through the NITheCS funding, they made a call for collaborative projects last year, and we did advertise it widely through our statistics community. But as you see, they wrote in red here, they were very disappointed that they only got 1 application to come and work with them from CPUT, which is at least an HDI. And I think the reason for this is the sort of intensity of our academic programs at our universities. Statistics is incredibly understaffed at all universities across the country. And when staff see an application like this, obviously they're like, wow, that's a great idea. And I actually spoke to a few people across the country and encouraged them to apply. But then when they get down to doing it, they're like, when could I possibly go to Stellenbosch and spend a week there doing research? So it's the capacity issue really hampers the idea of going to do research. And it's not that there's no one who could apply and come do this. It's just, people are completely overwhelmed. And we have a very, very young community in statistics, so it would be a great opportunity. But people just are not taking that next step. And it's absolutely not for lack of trying and reaching out personally to people or anything like that. So I think that's just something, it's a challenge, obviously, and something that we would continue to chip away at, but I think it's a reality. Okay, the multidimensional visualization continued as well. So these are the projects that's going on inside of there, so within the group. So biplots incorporating spatial weights, the Move Easy package, some more progress there. And then 2 application areas, biplots for thermal and emissions performance, and also biplots for linguistic patterns. And they presented at the DSSV conference, which was held in South Africa last year. It's a national conference, but at the Kruger Park. And in fact, this team basically organized it at our SASA conference at the end of the year. And then they also have done 2 NITheCS Monday afternoon seminars. Okay. Right, and then the last theoretical one is actually Priyanka's one. She's back. She'll add something in if I say something wrong. So during last year, they've been planning and just getting everything going. And for this year, they've got a few planned activities. So they've got very big international collaborations, some leverage funding, and they plan some international visits, some nice collaboration. And then they've got a few planned projects here to construct frameworks for directional data on non-Euclidean manifolds, specifically nice applications in air pollution and wind energy, advanced model-based clustering techniques to detect heterogeneity and anomalies in multi-dimensional data sets and application areas, and then also to integrate these approaches to produce flexible, interpretable, and scalable methodologies across diverse scientific and industrial domains. So there's a lot of theoretical backbone with all of these work factors I've shown you, but there's always a focus on where can we apply it, where can we collaborate, which is obviously very natural coming out of statistics and computer science, machine learning, data science, etc. All right. So the second pillar is the academic sustainability. So I alluded to it already, but statistics in South Africa is a huge capacity issue. And in addition to the capacity issue, we have lack of mentorship. So I'm one of the oldest people in a community, and I'm not young, but I'm not old. So all our sort of experts and the profs that everyone talks about are already retired. Yes, Wednesday. When was Prof. Demet's birthday? Wednesday. One of our statisticians here in Stellenbosch, I don't know if they were in Stellenbosch, had a birthday for him. They should have. 80 years old on Wednesday, and he's one of the pillars in our community. But he's 80 already. So we have a huge gap. So we have a real issue in terms of capacity development and staff overload in all of our departments, small, big universities, HDIs, non-HDIs. So one of the pillars here that we put forward into this focus area was capacity development. So where are my slides? All right, I'm going to go back to that slide. So they changed around. So StatsNet is something that I initiated in 2020 within our statistics community, and it stands for Statistics Supervisor Network South Africa. So that's why there's a capital S. It's not just to make it look nicer. And it's really about, so we started off to develop doctoral supervisors because we don't have these senior professors to mentor. But it's grown more in the sense that it's now really a general capacity development of an academic. So how do we grow our academics as together as opposed to a mentor growing downwards? So we help each other, basically. And so we, as part of our work package, we held a workshop in January here at Stellenbosch in this very room. And it was 2 days. So day one was really about the statistics network, about developing capacity and finding out what people's different problems are at their institutions, what are their hurdles in their career, what are the things we need to do, etc. And then day two, we did a workshop. I presented a workshop on writing for impact. So how do you take your theoretical statistical concepts and convert them into something that the media could understand? Or if you don't want to go that far, even just into applying for a grant. So writing a grant for an international funder who's not wearing his statistician's hat, he's wearing I want to fund world hunger or whatever, okay? And this was really interesting. So we didn't have a lot of people. We had about 10 people come because we obviously are within the focus area, one of the work packages. So we only had 100,000 Rand, but we focused on bringing in HDIs. So we had 2 from Northwest Mafeking campus, 3 from Venda, and 1 from BUT. And Stellenbosch was obviously already here, so that was not a huge expense. And that was really interesting. So it was very HDI driven. And then we had a big discussion about the different issues at the departments, but then also how to write for impact. And this was, so we all think we can do that, but then when you sit down and you think about it, it doesn't come out as nicely as you would like it to sound. So I thought that was really eye-opening. And one of the things we discussed there was actually master's degrees. How do you pitch? How should you examine a master's degree? PhD is obvious. That's the end of a student's studying. It has to be novel. They have to be able to stand alone as an independent researcher. It's not straightforward on what field, but the outcome is very clear. Master's degree is not so clear. And in statistics, it becomes very difficult because you start getting master's theses that you examine that are just a data analysis. So they've taken data and applied a technique to it and they publish it. Okay, they put in a thesis. That's not a statistics master's. That's another field. Right? In a statistics master's, you have to show that you've mastered statistics. not a data set in public health or whatever. So we had a very nice discussion about that, and we actually want to do a workshop for the statistics community later on in March, April, online workshop to have that sort of discussion with staff at the departments and possibly masters. So this was really, really nice. And we're going to do, so we had a lot of applicants actually for the workshop, but we couldn't fund them all. So we're going to hold a second workshop in May with our next year's budget, when Francesco says we've got it. And we'll do that up in Gauteng because the other applicants were all from the central part of the country. And I thought that, yeah, that was very nice success. Right, so sorry, let me go back to so the third pillar is this community collaboration, and that is very much about who needs the analytics skill support from our focus area, and not just the people in the focus area, but the community of statisticians, computer scientists across the country. So we did some initial presentations when we were here in September, and so Stefan is in charge of this one, and he's planning a workshop with the funds that he's got with the Space Research Centre at Northwest University, and they're going to have a collaborative meeting just to see if they can figure out where we can help in that aspect, right? So that's just one of the things we're doing, but this work package as a whole is something we really want to take further. We wanted to be at Pedro's workshop that he had a few weeks ago, but couldn't be there, fortunately. But I think the analytic skills and where else it's needed is really important discussion that we have to have. And I know whenever I see Francesco, he says, when are you doing more AI and more? So absolutely, it's very, as part of our planning, it's very, very much there. Yeah, so just to summarize, it's our three pillars: theoretical advancement, sustainability in our communities, and obviously about bringing in HDRs, but we definitely already there in a good spot. That's just a picture of everything. And then in response to the analytics sharing, we are planning some mini schools in 2026. So in April now, I've already organized with Nelly. We're going to do an introduction to machine learning mini school on Wednesday afternoons. And then Marley and Tian are going to do that deep learning bootcamp they did, but obviously a very watered down one because it's only 4 hours after that. So that will be May. And then I know you've done a Python one, so we'll do an R one, if you're happy with that. Okay, very good. And then, okay, so I've got question marks. You can tell me what the others you want. And then someone suggested an extreme value course might be something that you would want. So we obviously have statisticians who are experts in that, in climate and other areas. So that's a question mark as well. Yeah, and then I don't have a challenges slide, but everyone was talking about challenges. I'm also just going to say the money is a problem. We've got a few people at UP who have got the women's writing workshop money, but it's still not at UP. So we're not going to be able to use it before the end of March. It will be impossible. Yeah, but yeah. So I agree. I understand what you said about the process of transfer, and I think that's all fine. I do think we need to have maybe a fast track of transfers of NITheCS money, maybe between the institutions, instead of this 30-day lag. Something like that might make a lot of, yeah. Okay, and that's my last slide.
Okay, thank you very much.
Any questions, suggestions?
Workshops, mini schools?
No, just a correction to the mini schools.
Yeah.
It's 4 afternoons a month. Yeah, some months it's fine. And it can easily be also 1 hour and a half or 2 hours.
Oh, because you can do a little bit longer. Okay, I'll tell them if they...
More than 2 hours, people don't stay.
Yeah, exactly. Yeah.
An hour and a half.
Is also okay.
It's absolutely fine.
Okay, then I'll tell them because maybe it'll be easier to present if we have a little bit more time.
You know, that's a formula that the brain seems to work.
Yeah, I also think so.
But you know, we can always organize longer schools.
Well, but I think it works because people don't have time to do longer. The presenters.
But
yeah,
what we started seeing, for instance, last month we had introduction
basic introduction to Python. There were 500 people for 4 weeks. 500, not 10, but 500.
There's a huge need.
And now maybe after you do machine learning, we do introduction to advanced Python. Because they are desperate to have more. So don't underestimate the impact of these monthly events, because there is really a desperate need for it. And what also works very well that we started last year are the micro schools. That we do on Friday at 12. And that's intended kind of for peer-to-peer training. We ask masters, PhDs to share 20 minutes one school. We work with Matplotlib. Last week we had use UV for Python. Do you guys know UV for Python? No, go and watch the videos. It's a kind of new anaconda thing that is much better, much faster, much here, much there.
That's cool.
What's for Python, sorry?
I haven't used it. Mesias?
No, I probably missed this, but I saw that you have some few publications, especially the R package, but overall in your focal area, how many publications that you have had?
I know morally, I've got it in that report we did, but I didn't realize we should put it on. Obviously, everyone's done it. I don't think we have as many as the other two presentations we've seen, but I think in statistics and computer science, public publishing is much, as you know, much slower than
So you mentioned that there's real capacity within the community. Did you see some growth or?
So I think we did have, and Priyanka, you were part of that NRF crisis granted. So in 2018, when was it then? Around then, 2017,
2015, 2017, around there.
So we actually as a community got a specific ring fence grant from NRF back in 2015 to pay masters, so like full-time, to get more masters and PhD full-time. And we have seen a growth, but I don't think we will ever be able to keep up with industry. So the pool for analytics skills is just enormous. Like we can't produce enough students.
For instance, Mesias, who runs our quantitative finance thing. The quantitative finance guys managed to get a special grant from the STI for the use of machines.
But that's what Luiso is doing.
Sorry?
That's what Luiso is doing for our maths. That's his,
Statistics, we also. Right.
No, but we're part of Luiso. No, we're part of Luiso's structure. Statistics is with.
No, not Luiso.
No, that's different.
I'm speaking of collaboration with industry. And get allocated funds for this support collaboration. That's what Mesias is doing in finance. And they give them 2 million.
No, industry is the way to go.
So why don't we write a proposal for the STI?
The STI.
There is need for this. That's
okay.
I mean, I like your work. I mean, to make sure that the statistic is acknowledged. Because this is also a critical skill. I mean, even in our department, it's hard to get staff to teach in both of that. I mean, you can pitch to DSTI in such a way that you recommend them that they should support this field of study.
Because that's what also the climate change guy. He had a specific work.
So it's
convince the STI to.
But climate change and Mesias have the distinct advantage that there's a direct collaboration. If you go for all of statistics, we're not all working in the same. We're not all working in finance. In fact, very few of us work in finance. Mesias is one of the.
There are other potential interesting collaboration.
Yes, 100%.
But regarding, your failed Moviso workshop where only one person came, why don't you start with a mini school just to advertise?
That's not Priyanka's
great interest, and then they come and start.
No, but I think they did when they did the two, because they've done 2 Monday afternoon seminars where they directly do this, and they have advertised there. I don't think it's that people are not keen, because I've spoken to a few people who think it's a wonderful opportunity. But to get a week off from our teaching is just, yeah. And I know it's always an excuse, but it is really difficult. But they'll pursue it. I think we will.
In like 2 days instead of a week.
Yeah, 100%.
Two branches.
Absolutely.
Yeah.
I don't know what the Mobisu workshop, if it was a workshop or what the intention was. I'm not sure if it was an intention to find collaborators from other institutes of their group, but then that's an entirely different idea. But regarding the funding structure and that, or industry collaborations, the difficulty with our field comes in, then you're not building your capacity in academia. You're building your number of postgrads.
Yeah.
Right. But then after that, with a lot of the industries, the expectation is that they go and work for them.
Yeah, and we lose them.
So then you're not retaining them within the environment that you would.
It brings in money, but it doesn't solve our capacity issue. And it probably exacerbates it, because now we've shown industry all our amazing postgrads, which I'm not saying we mustn't do, but then they take them because they're looking for analytics people.
But of course, Ingrid, of course, what I expect is the project to be resulted in a peer review publication that you.
We have no issue publishing. Our research outputs are fine.
And that's get on your advantage as an academic.
Yeah, but we have our community publishers. We're not doing research, and we're not producing postgrads. We have actual staff issues. That's the core issue. It's not, we can publish, we present internationally, we none of that, we have rated researchers, none of that is a problem. It's to keep academics in academia. Yeah.
Thank you so much before. You should get more AI in your title. Because then the money starts flowing.
Okay.
And people stay interested. I know it's there, but it's not everywhere. Not everywhere. Yeah. And that is what people want to see now. You know.
Yeah. But you know, we on purpose haven't put AI there because we're much more than AI. But I'm not disagreeing. So what if we say?
So it's a market.
It's a market, 100%, 100. Yeah. So we could make it statistics, AI, machine learning. Yeah. Then it would.
To say,
this
department does now AI.
But we don't do. I think it's really important. We don't do research in AI. That's the job of the computer sciences. But of course, we have computer sciences. Yeah. Absolutely. No, absolutely.
I would consider the market.
Yes. Yeah.
Domain or not.
No, you're right. 100%.
No.
I think they will go there.
Inka,
yes.
A question here, please.
Okay, sorry, I might have missed one of the event, but I think last year we kind of talked about having people from different disciplines that make use of statistics in the loose term. Because what we're seeing is it's in some people and some research there are like flaws under analysis. So for instance, this idea of look ahead bias, that people are just gonna like take the data and do things. In some case recently, I think it was even a published paper where it was kind of an event study, but then the data were randomized for some reason. But then if you do that, you miss events. So it seems as if there's a kind of a need to help those that are working with data of the pitfalls of all those other things, and that is
okay. So that is still, absolutely. So we posed that last year, and we're very much still thinking about that. So if people are very keen on that, then I will take that back, and we figure out a way to do that this year.
You know, we have. I've been playing around with this idea for a while now. We have the SATAX courses that are essentially taught and broadcast. But what we should also consider is to develop online courses, that people can then take at their own time.
But you have to
broadcast. like a Coursera, edX or whatever.
You have to have a unit that will contain that.
If you had the concept, we find the resources. And we develop a course, introduction to AI for everybody. Yeah? Probably one email to the STI, the money is there because they're desperate.
Yeah. So we do that at UP. I do that. I have short courses like that, self-paced. Yeah.
There's level for short courses and use them to
But people want the difficulty. People want a certificate if they pay for a course.
You can give them the certificate from university, from Stanford, wherever the students are.
But it's not that easy. It has to be through a unit that's authorized to give a certificate. That's why, it must be done. Yeah.
Also think that
100%. Bianca?
Okay.
Sorry, Bianca.
So maybe one last question, and then we ask the next.
Note, I think it's also important to differentiate between, as you're saying, developing a cause and building these skills in terms of like a consultation service versus the focus on developing a field.
Yes.
So this type of cause or this type of assistance is a consultation-based service. It's not necessarily contributing to our research profile.
But that's why we have those 3 pillars. That's why we have split them into our research and then collaborative. And we didn't want to put the consultation word in because it looks bad, but that's what the last one.
That's what it is.
Yeah, that's what it is.
Not put it in because it looks bad.
That's what it is. 100%.
Right?
Yeah.
So, and I think we just need to see it. If we do things like this, it's more the mini workshops, as they're saying, the online courses, things like that, versus something that is contributing towards the field itself.
This idea was like
or publications or things.
That's it. This idea is like a brainstorming thing. So someone in another field could say, this is what I'm doing. And then a bunch of statisticians and computer scientists go, try this. Like, not that you get involved and you do the work, that you brainstorm with them. Okay.
Thank you very much.
Thank you.
The name of the Python package you're talking about? The Python
Introduction to Python. UV.
UV.
Okay.
Yeah. Are you present?
Yes. Yeah. It's like an anaconda, but written in Rust, and that's why it's very quick. So I think I will present from there, not from my laptop, because it was telling me that the NITheCS connection is not very stable. Because I have a little video.
That is essentially my cell phone. Yeah.
No, I mean, okay, let me present the PDF because there was a little video from Thomas. You can skip it.
You just put on the microphone, please.
In the middle, we'll need to swap. There'll be 2 speakers for the one presentation.
Oh, yeah, they go over to that.
What's happening? Okay, good. Okay, so already good afternoon, everyone. My name is Ilya Sinayskiy, and I will present the part of our focus area report on the quantum technologies, which were called on some stage quantum technologies for sustainable development, and now we're just quantum technologies. We just need probably update a little longer of our focus area, and we have principal investigators at UCT, Sajid and Jeff, and at UKZN, Thomas and myself. Yeah, and our coordinator is Jeff, but he was have some other commitments. That's why I will present, and the primary collaborator in at the UCT side. Jaco will present the UCT side of the story, and I'm deputy coordinator, and I will present essentially more or less what I have been doing and what Thomas has been doing at UKZN. And we have several kind of participants in our projects, which are kind of spread around the country. Okay. So what are we doing? We are doing kind of quantum technologies, and it have two kind of basic angles of how we can view these things. One's are related to the technologies which have some potential of implementation in some hardware sort, and that's related to the development of so-called quantum batteries or practical development of the practical algorithm for the quantum communications. And we're also developing the tools to analyze and how they can be used for kind of for development of the quantum technologies or for the use of the quantum technologies. And we have kind of like generic approach to the quantum development of the quantum information tools, as well as development of the approaches to the quantum simulation and quantum computation. Okay, so we have quite a few goals to our program, and they are also kind of in our kind of standard statement. So we want to do quantum batteries, we want to do better quantum communications, we want to advance tools in quantum information science. Yes, we want to be able to use quantum computers which exist currently. It means that in so-called NISQ era, so we need to have ability to develop corresponding algorithms so that we can extract some useful information from these essentially very large noise-producing devices. And quantum computers which might exist in the future, which are called fault-tolerant universal quantum computers. So far, they do not exist. Yes, and using these kind of algorithms, we want to solve several problems with the focus on the simulation of open quantum systems or kind of just large enough systems with a generic, with kind of various interesting properties. And of course, yes, we still also need to do the training of the PhD and master students as everybody else here. Okay, so first I'm going to talk about the highlights of what was the achievements and the highlights of the work package which is related to quantum communication, and this was mainly done by the Professor Conrad at UKZN. And what their basic idea, they're planning to kind of develop systems of the quantum communication, but not just standard classical or traditional quantum communications which exists. The idea is that you can use additional degrees of freedom of light to compress more data per transfer, for example, single photon, and so on and so forth. So, and this is called the design a high bandwidth teleportation scheme. So that when you use, for example, orbital angular momentum of light, also including kind of to encode your data and reach more higher rates of the data transfer. Okay, so, and they have done some progress in that. They have also done some progress in, they finalized some works related to the measurement or weak measurement approaches to the reconstruction of the physical systems, as well as the people who are dealing with the quantum communications, mainly with light. Thomas and his collaborators have done some progress on the approaches to the optimal cloning of the spatial modes of light. Okay, so the basic ideas, and I'm just going to flash a few slides, is that they developed this approach with the teleportation, with the kind of the two types of so-called quantum teleportation, which is directly applicable afterwards towards the quantum communication. One is when they essentially take a large signal, and they decompose it into the modes and teleport each mode simultaneously, and kind of in the one exchange way. So, and for that they need to define something which is called the pixel modes. But this they have demonstrated experimentally, and this is Thomas and his collaborators on the theoretical sides provide the theoretical framework, while Andrew Forbes and the group of the structured light at WITS provide the experimental implementations. Okay, so there are some, this is a typical optical setups in this field, and they presented kind of these results are currently under review and available in the archive, and they, of course, if they report the result, they obtain a very good transfer fidelities and so on and so forth. that's supposed to be a video, which we are not going to see, but there is also this standard approach, one of the approaches related to the monitoring of the quantum systems, which is called weak measurements, and they have done some work with that, and this was a very, very old work. And by the moment when one of the people who was involved in this work, Emiria, she managed to get a PhD at Stellenbosch by the moment when the work is done, which also happens recently. Yes, in the end of January. Okay, and the last bit, what Thomas have done with his sub-project is related to the problem of the optimal cloning of the modes. So it's a standard problem. It's a standard problem, so that that if you have if you need to clone the quantum states, but not at one go, but into the several attempts, you need to apply certain optimal strategies how you can do it, and this is contributing towards that goals. Okay, and Thomas have been involved and coordinating quite a bit of outreach activities. I mean, besides the fact, they have submitted some papers and some that have been published. They graduated a couple of students, so they're still in the progress. Thomas at UKZN have been very active in organizing Science and Jazz series, where there is kind of it's used as a popularization tool of science, and very often there is a guest speakers, and the speakers and musicians discuss some constants, concepts, and it's all a little bit easygoing, and it's like, I mean, there is no strong academic rigorosity in those kind of discussions. It's clear, but it's a little bit of popularization of scientific ideas. And also Thomas is quite involved into the into organizing the workshop across the Africa. Okay. So now I will speak about a few words about what I have been doing within my work packages, which are related to what is called the quantum simulation and quantum computing. And essentially, the quantum simulation, for those of you who are not aware of it, it's the way, kind of an approach is how you can use quantum computers not to break the RSA, but how you can use the quantum computers to simulate another quantum systems, such that they're so large so that you cannot, in principle, use any other traditional approaches to do it, or it's very difficult, or the precisions which you can achieve with the traditional approaches or classical supercomputer approaches are not good enough. And there are some certain mathematical guarantees which are telling you that if we have a quantum computer of the future, we can definitely do it. But so far, we don't have those quantum computers, but still one needs to develop an algorithms for those quantum computers and so on and so forth. And kind of like we have a result and an improvement of our result on the algorithm, which is called Q-drift, which I will flash down on the next slide, which we adopted to the theory of open quantum systems, and we applied kind of enough to obtain some tighter bounds for the errors which one can get from this algorithm. Another activity which I was quite involved with is, together with Francesco, the co-supervisor student here in Stellenbosch, Matt Lawrence, who developed so-called domain-specific language. So it's essentially a special formalism which can be applied to the construction of the quantum circuits to efficiently design an algorithm for the different purposes. And this language was developed a couple of years ago, and this year we managed to have a very interesting application of this language for the problems in the condensed matter physics, but also the structure of the language allows us to design hardware efficient algorithms which could be applied on the modern currently existing quantum computers. Also, this year we have done some efforts in contributing towards what is called the kind of non-traditional approaches to computing, and within that, together with PhD student, we have been working on what is called open quantum Brownian motion. And we have done get some results there, and also using some ideas. Can we use some bio-inspired ideas for the better design of the computing algorithms? Okay, so I'm not going to explain that too much because all the details are in this archive, which we are now going through the iterations of submitting to Quantum, and it was also kind of reiterated last year, and it will hopefully it will be reiterated for the last time once more this year, and it gets published. But the idea that this algorithm is demonstrated a very good performance, and Essentially, the performance process much better seen on this graph. So if you apply this Q-drift algorithm to some prototypical systems, you can plot on the one scale, on the one axis, the size of the system, on the other, how the complexity scales, and essentially what you see that this Q-drift algorithm shows the best possible, essentially scaling performance, and that's what you want. Because essentially, in the moment when you have this large enough computer, it's not only the problem that you cannot simulate something. The problem is that if the quantum simulation, take for too long, it's also practically mean that you cannot simulate it. So you want always to think about these aspects as well. Okay, so and within the same algorithm, we apply some other fancy mathematical tricks to even better to improve the performance to reduce the necessary number of steps to perform to get the good results. And we've done it in the both unitary approaches, so that we kind of get a better estimates for the complexity in the unitary approaches and the open approaches as well. And this is submitted and hopefully soon will be published. Okay, so now very quickly about the domain-specific language, which was developed as a little kind of game in quantum machine learning, which could be applied to the various systems. And afterwards, it was realized that this is much more interesting concept, which could be generalized. So kind of it was published a couple of years ago. And this year, Matt generalized it and began to apply this domain-specific language to find the optimal architectures for the different models, and we have shown that you can construct, for example, very efficiently ground state ansatses for some prototypical systems, and that works very well. And it works so well so that we even managed to publish it in PRL. Okay, and just also very briefly, few words about the alternative approaches to quantum computation. So with Ayanda and Francesco, we have performed the macroscopic derivation of open Brownian motions, which are very interesting, open quantum Brownian motions, which are very interesting systems, where you have a little quantum system which is attached to the classical degree of freedom, which is like hybrid quantum classical systems. And this could be seen as the way how one can use the classical degree of freedom to control quantum system, or as the measurement device. And this could be useful also for computations. And we have some results which we just submitted and also hopefully will be published soon enough. And the last bit which I will speak about is there are some ideas about what will be the possible structures which are happening, kind of quantum relevant processing in the human brain. And over there, we have also done some proof of principle models together with Francesco and currently a postdoc at Stellenbosch with Bethany Adams. Can we get some kind of proof of principle ideas, and can we get some inspiration from so-called postdoc clusters to do some computation? Okay, so very briefly, the students which were involved in this kind of bit which I was dealing with, this Ayanda, who submitted and his PhD, and hopefully will become a doctor soon enough. Matt, who is already also Dr. McLawrence, Yen Shivani, who have been busy with the quantum simulation and the classical simulation of the quantum systems, and also several master students, Sarisha, Dylan, and Dia. Dia is a master student here, and while Sarisha and Dylan are master students at UKZN, and also a couple of postdocs, Dr. Kimara Niker and Dr. Bethany Adams, who are postdocs at UKZN and Stellenbosch University respectively. And as very quick, brief looking forward for me, so what do we plan to do hopefully within generous NITheCS support? We plan to keep developing quantum algorithms for open quantum systems. We're also trying to develop an algorithm for solving partial differential equations on the quantum software, and as well as we have a kind of ongoing effort and the progress in the development, deployment, and benchmarking the quantum algorithms on the currently existing quantum computing software. And of course, standard things of the subclass of the quantum algorithms, which is related to quantum machine learning. And of course, this is a standard phrase. Okay, and I think now I need to switch to Jaco, and he will present the other side of the story.
Right, great. So we'll just see if all the if Yeah, afternoon, everyone. So I just want to give feedback on the other 3 work packages that fall under this quantum technologies umbrella, and that being quantum batteries, quantum information theory and theoretical physics, as well as quantum foundations and quantum imaging. So you may have noticed I'm not one of the principal investigators. That's Jeff and Shajed. Jeff is unfortunately in Johannesburg. Shajed has just returned from an overseas trip. So I volunteered to just present the results from the work packages for today. But I've been involved in most of the works that you'll see here, some greater or lesser degree. So please feel free to ask any questions if I. So I just want to start off actually with student development. So in terms of the outlook of the quantum technologies, we envisioned to have at least 1 PhD and 1 MSc student graduate from each of the work packages on a related topic, and to have 2 publications annually in each of them. So I just wanted to stop first on the students that were involved in these projects. Jacob Lund and Jordan Moore for honors projects that are in this field, but I wanted to include them because Jordan started a master's program on the quantum batteries actually, and I had some very promising results, but I had to be put on ice before he accepted the position for an MSc in Oxford, and we are still looking to find an MSc student to fill that position. Jordan's also happy with that arrangement, and then we'll continue his work from there. But that's a very good foundation that I think there's some good results in hysteresis of quantum batteries. Jacob Lund is an exceptional student, truly remarkable. He's published in a number of different areas. I'm not sure if he will be in any of the fields that's mentioned here, but I wanted to include him as well. He's also appearing in some of the publications. There were 3 MSc students, Zaid Pandit, Tanto Tapo, and Saad Gul. We finished the MSCs on the 3 of us in some capacity. 2 of them are now pursuing PhDs. Saad Gul has just submitted and put out PhD applications at the moment. Nita Gupta finished with his PhD, is now a postdoc at Janelidze University in Poland. Cameron Beta submitted his PhD, fortunately not in the system anymore. So all of the students that mentioned here are still in the academic system in some extent, but Cameron has accepted a position in industry. But we're still very happy that these students are still active and doing research, and we keep in close contact with them as far as possible. In terms of the structure of how we treat the students, we really want to empower them to become independent researchers. I think as everyone does, very difficult task, of course. And the best approach that we've come up with is just to involve the students into these projects as actively as possible. So we meet once a week, encourage them to come up with their own ideas, or even just share interesting papers that they've read, and then we can start to think of interesting directions to take research in. For the coming years, we hope to continue these efforts, but also have a strong throughput of students. And this starts already at the 3rd year level. At UCT, there's 3rd year research projects that are offered as optional courses for 3rd year students, and we annually offer lots of them. And this year especially, there's been enormous uptake from the students. We might have a bit of a shortage, but we'll manage. Onto the work packages first. So the first work package I just want to comment on is quantum batteries. Also in brackets and technologies. A lot of these works are more closely related to quantum thermodynamics than quantum batteries. So we envision some application batteries in the future. I'll comment on that in a few slides as well. Involved in 2 of these papers. One paper that I just want to highlight specifically, I didn't include all the details. I just want to highlight one in particular, which is asymmetric complexity and the quantum Mpemba effect. What the quantum Mpemba effect is, it's related to the classical Mpemba effect, where it was observed that an object that's hotter can cool down quicker than an object that's colder. The quantum version of this, at least the way it's understood now, is that state that's prepared further from symmetry can restore symmetry quicker. Under Hamiltonian evolution, that restores that symmetry. And in terms of charging protocols for quantum batteries, this is where we envision this being particularly applicable, where your charging protocol involves some symmetry restoring Hamiltonian, and you want to understand the optimal usage of quantum batteries. Maybe better to break the symmetry further than it will charge quicker. But this I'll comment on in a few slides again. So now these three preprints that we managed to produce. I should also just mention that it's sometimes a little bit difficult to partition the works between these different work streams. They feed into each other quite a bit, but I've done it as best I can here. So here's three that I'd say are more strongly related to quantum batteries and technologies. Yes, 5 of them that I'd say, oh, I think one may have been cut off and one of the, regardless, yes, these ones in quantum information theory and theoretical physics. So here you'll see again students, Zaid Pandit, Cang, Syed Gul, were all involved in these. These were more theoretical developments on quantum complexity. You're essentially asking what's the least amount of work that you need to put in order to prepare some target quantum state. And you can think of it in Krylov complexity, which is the type of complexity we're most interested in, as you can prepare quantum states using superposition and actions of the Hamiltonian, time evolution in other words. Using these, you can build all the possible target states and you can ask questions about how difficult they are to prepare. Again, I'll comment on that a bit more in a few slides. Finally, on the quantum imaging and quantum foundations, there were these 3 preprints and papers that were put out. One that's certainly in this is a paper by Shajid and some of his collaborators on arrival time, a classical parameter or quantum operator, certainly within this realm. We're trying to ask questions about quantum measurement, some of the unresolved problems of quantum mechanics, or questions of quantum mechanics, that's one of them. But one that I also just want to highlight is quantum computational perspective on spread complexity that we put out last year as well, where we managed to formulate Krylov complexity in exactly this way, as a complexity built from superpositions and time evolution. And what we didn't state explicitly in that paper, but is going to be a future direction, is that we believe that there's a possible experimental protocol to actually measure Krylov complexity. And this is one of the directions that we want to take. The future direction in particular is closely related to quantum batteries research. So the way this came about is that Jeff has been thinking for a long time that he wants to build a quantum battery prototype. Of course, for quite some time, there's been the theoretical tools to do this, but not necessarily the practical tools. But in the last year, we've been having a lot of active discussions with the group of Mark Blumenthal at UCT, and they have what they coin the coldest place in Africa. It's essentially ultra cold atoms that they can study with high levels of precision on several 2-dimensional substrates and the behavior of these. And we believe that there's scope there to actually build a prototype quantum battery instead of different materials. The reason that this is feasible is that Prof. Blumenthal has a grant that's been given in collaboration with Cambridge, where the laboratory in Cambridge will be synthesizing different materials that they will be sending to his lab in order to study in this ultra-cold setting. So the idea for us would be to align our research in quantum batteries more on these 2-dimensional substrates, find appropriate models, certainly align the student projects in these directions as well, find appropriate projects, have some collaboration with Blumenthal's group, obviously have discussions about the amount of time that will be needed to measure these, what's the kind of measurements that are sensible, and so on. So we envision in the next year to have some significant changes on the projects on the quantum batteries due to this, but we're very excited about it, certainly. But the other work packages will be affected in some ways, but not significantly. We imagine that the packages will still proceed as per usual. The significant challenge that we have at UCT at the moment is just that we have 3 key collaborators, and we're trying to enlarge the network as much as possible. This has certainly been a challenge, one that we are aware of. We are hoping to organize more workshops, invite more visitors to try and extend our network as much as possible, and extend collaborations within South Africa and outside as well. That's all that I want to discuss. Any questions are welcome.
Okay, thank you very much. Questions for Ilya and Jaco? Hi.
So we've seen a lot of very interesting research happening. You've shown these as sort of separate strands, and some of the other groups presented how they tried to somehow put them together.
100%.
So what are your what's that you've been doing, or your plan perhaps with that?
So certainly, I think that is the main shortcoming at the moment that we have, is that there's sort of these two separate streams. They don't really talk to each other a lot. Best I think we can do is to try to organize a joint conference and workshop in that case. I think that's been an excellent tool that other groups have used in order to facilitate that. I should add that I think one of the reasons for this is the fact that effectively this stream is split into two. You've really got two key primary principal investigators from the institutions who already have existing research programs, which is why I think it's been very difficult to integrate them. But we are hoping to do that to a greater extent. Workshops, conferences, I think is the best way to do that.
Other comments? Or is everybody hungry?
So just not ignorance. Why would I want to buy quantum batteries? Is that more capacity or charging time?
So it's so the main reason that people are really interested in quantum batteries is I should have mentioned this in the slide. So thank you for the question, Kostas. So what you're leveraging, and this is true for any quantum technology, you're trying to leverage superposition and entanglement in some way in order to get what's called a quantum advantage over the classical counterpart. So, and what you have in the quantum battery is through superpositions and entanglement, you can actually charge a set of batteries simultaneously. So what happens is that the charging time decreases exponentially with the number of cells that you have in the battery. Which is why it's now, of course, one of the first questions you would ask is, how big can you make a quantum battery and retain those properties? Probably would be my assessment, but it would still have some applications in certain circuits. But that's the main reason why it's very interesting. There's far more efficient charging capacity.
But you need to put it at 3 degrees or something for it to work?
I think so, yeah. So, well, at least the experimental setups are trying to work at individual atoms to have really tight control over the quantum system that they have. It might be plausible to do it in a more macroscopic system once the sort of single Hamiltonian, battery model is well understood. It might be possible to do it in a macroscopic system. Predictions of this.
Any other question, or is everybody hungry? And I hope that there's some food outside. So we will thank you very much, Jaco and Ilya again. Another hour. Zurab, people check.
And do you really care about the minute?
Okay, so the next speaker is speak about the cognitive finance.
Yeah. Thank you. Thank you very much, Francesco, for the opportunity to present the reports or the way forward for our research program. And we call our research program is called Quantitative Finance Research Program of NITheCS. And the main theme of our research is actually driving innovation for finance sustainability. And so in our research programs, so I'm the coordinator with Duffy, who is from the University of Johannesburg. And we also have quite a lot of, we also have another coordinator at the University, Northwest University, who is Helhat. And we work well together, and I'm going to unpack all the things that we are currently doing. Yes, so I'll tell you more about who are we in a quantitative finance research program. Then I'll also look at the way forward in 2026, and also look at the industry-directed research program that we're doing. And our program is actually different from the rest of the NITheCS research program in a sense that we have this a special funding from the DSTI, and this funding is actually was purposely for enabling us to bridge the gap between academia research and as well as the industry. So basically, the Department of Science and Technology and Innovations actually give us 2 million, and this 2 million is meant to be, we get problem from the industry and we distribute this problem to academia that are working in the risk space or quantitative finance risks of finance. And the academia respond by actually writing a proposal on the way how they want to tackle this problem. And then once the research proposal is accepted, and we sort of fund the project, so the academia and the industry, they collaborate in that project, and sort of, but the criteria that we want to make sure that the problem is solved. And as well as at the end of the project, the paper or the project is, of course, is published in a peer-reviewed journal. And yes, so I'm going to talk about that later. And of course, the stakeholder engagements are how many like students that are involved into this, and also the banks, the banks that we're collaborating with, or the financial industry that we are collaborating with. Yeah, let's jump in. So basically, we want to build a community in quantitative finance. So quantitative finance is a program. Quantitative finance really means you are using numerical method or quantitative techniques to solve problems that result in the financial industry or maybe in the finance area. So basically, it's called, sometimes they call it financial risk management, sometimes they call it mathematical finance, sometimes financial risk management or financial mathematics, or any quantitative risk management area. So those are what we call the quantitative finance. So what we want to do is to build a quantitative hub in South Africa. We want to make sure that this area is well appreciated in South Africa. And I'm one of the, an ambassador for the cause. My aim is actually to preach a gospel to make sure that this field is well appreciated from international perspective, also from the local perspective, to make sure that we appreciate the level of technicality and the usefulness of this field in South Africa. So we focus on derivative pricing. Derivatives, that means, are the tools that one can use to manage risk or to transfer risk from one entity to another entity. And this derivative pricing was very common during the, the grow up from early 2000 up until 2007. There was a global financial crisis, and these derivatives were misused because even people from accounting, investment management were using these tools, but people, they underestimated the assumption behind the model, and the field was heavily criticized because of the global financial crisis. Many people, even in the big banks, they were using the techniques, and what they misunderstood the use of the techniques. And even the big banks that were too big to fail, they fail because they don't have the right mathematical techniques to be able to. So we are trying to revive the field of quantitative finance, and I'm also very thankful to the Department of Science, Technology and Innovation for appreciating this field. And we do risk management. It's actually very important because risk is everywhere. We have seen it already from the global financial crisis. We have seen during COVID-19 that, of course, risk can come from nowhere. But now, because of that, we need new mathematics that are able to deal with new phenomena, new risk appetite. So we need a lot of new mathematics to deal with this, in terms of risk management. And then we have benchmark reform. And I have to tell you, so interest rate went through a lot of development. From the global financial crisis, before the global financial crisis, people used to use single frequency curve. After the global financial crisis, they use different curves, what you call the multiple curve framework. And because they want to model different sources of uncertainty into one framework, and then after all, the interest rate that banks use to borrow from one another is called the IBOR rate. It's called the interbank offered rate. Were classified as risk-free. But after the global financial crisis, people see that the main interest rate, I'm sure you know LIBOR, that's the London interbank offered rate. These are rates at which big banks borrow from each other. And this rate was classified as risk-free. But after the global financial crisis, they see that banks actually tried to manipulate this rate, especially in 2012. Some big banks were actually even fined because they tried to manipulate this rate. So LIBOR, how it works, it's a panel banks. Every day at 11 o'clock, they submit a rate at which they want to borrow, at which they think is a proper rate to borrow from each other. And the panel sort of do an average of the rate that's submitted. Even in South Africa, we have what we call Geyer, which is a Johannesburg interbank average rate. But again, so there's a global reform to make sure they move away from that rate into a new risk-free rate, which we call the alternative risk rate. And this is what we call the benchmark reform. The benchmark reform, I was very fortunate to be part of the benchmark reform for South Africa, because South Africa now also moving away from Geyer, because Geyer is the average of the 5 banks, big banks in South Africa that used to contribute, and then the Reserve Bank and Johannesburg Stock Exchange now do the average of that and publish it every day. So I was very fortunate to be part of the LIBOR or Geyer reform, and I was invited last year because of the collaboration, the partnership we have in our program with the Reserve Bank of South Africa. I was invited to be part of the panel for the Geyer transition, and coming to the end of this year, there will be no Geyer anymore. There will be a new rate, what you call Zaronia, which is the South African overnight index rate. And this is, and again, it's very important for everybody to be aware of this, because it will affect, if you have a house loan, for instance, it will affect the mechanics of how you used to pay your loan. Even a man walking in the street need to know about this, because it will affect everything that's on your daily basis. And also, we have market microstructures. Of course, in finance, so we have the trading of the frequency at which you're trading. We have now what we call the higher frequency, and with that higher frequency, we have a lot of market microstructure that happen. And then, of course, we want to
develop of new techniques that are able to deal with this market microstructure. We also need a lot of machine learning and AI in finance. So these are all stuff in that we are doing in our program. There is sustainable finance. Last year, I hosted we host in our program, we hosted 2 workshops, and then I'm also editor in 2 international journals. One is International Journal of Theoretical and Applied Finance, and those workshops were accompanied with special issues, where one issue was actually going to be published at the end of this end of this month, where we have about currently we had about 40 submissions, but of course we're going to only to publish 8 papers in that special issues. And I'm also editor in the Journal of Futures Market, which is a Q1 journal, and this journal is published by Wiley. And last year we also have a special issue on sustainability finance and also in the emerging market area. So, but what we want is to make sure that we publish papers from emerging market and that are actually addressing the issue of sustainable finance and mathematical finance. So the main approach that we actually is to connect to the industry. And again, what we want to do is to bridge the gap between industry work and also academia work, because I think we all know that we don't want to have a wider gap between academia and industry. We want to make sure that we focus more on industry problem, but of course we don't want to relax the academic work. And of course we want to make sure that, again, I have to preach this. We want to make sure that even if we are working on industry project, we want to make sure that this project results in highly peer-reviewed publications. Yeah, so, and of course, we want to fund higher quality output, build postgraduate. Of course, we also fund from all the participating university and associates. We want to make sure that we fund quite a lot of postgraduate students so that we build the capacity in the field. Yeah. Again, I think this one I've already I said too much about this already. It's post-crisis market demand deeper tools. Before the global financial crisis, of course, that means the mathematical finance has gone through a lot of evolutions. So we need a lot of more new techniques. And the techniques that we applied actually, because social sciences is actually very dynamic. So that means, I mean, you can build up a model today, but after a few years, the models can be appreciated today, but after a few years, things has changed. So we need new mathematical thinking to be able to deal with this dynamic system. So yeah, so that means we need more deeper tools, mathematical tools to deal with liquidity. And the liquidity issue, like in South Africa, we don't have enough data. So we're actually working on a project with Eskom currently to be able to build up a model to hedge against the electricity market. But of course, the issue we have with, I mean, we invited one professor from Germany last week, but the issue that we have is we don't have enough data. Liquidity is a problem in South Africa. Model risk is another problem. Model risk is actually you try to solve a particular scenario, but you adapt a particular model, but that model is not actually suitable for that problem. So that all the risks that come from there, we call it model risk. Stress testing. Once you adapt your model, now how do you stress test your model to make sure that your model is actually very appropriate for that emerging market? Of course, like South Africa is one of the emerging market, and then of course we focus mainly on South Africa. And again, when it comes to here emerging market, South Africa, of course, is one of the. It has a dynamic economy, and this economy also needs a lot of new mathematical thinking, and especially into the field of finance. Volatility is one of the issues. The volatility is the one that actually used to measure the risk in the market, and the volatility in the market is actually rough. And here we need a lot of mathematical thinking in order to model that. Capital flow, and this is a project that we have with the Reserve Bank. 2 years ago, we ended a memorandum of understanding with the Reserve Bank of South Africa. But the issue there was they contract us because of they contract us and they give us money, and this money is actually to hire postdoc. And and then they work on the project. And this capital outflow is one of the problems, especially, Namibia and South Africa are packed together. But if South Africa, for instance, raises a repo rate, Namibia has to do that. Otherwise, there will be a sort of capital outflow between the two countries. So the project that we are currently doing, we want to make sure that we develop adequate techniques that are able to deal with that capital outflow. Energy transition, again, that's another issue. And we are working with, there's also in our research program, there's another project that's on renewable resources where we model the PPA, which is a power purchasing agreement. And this is a technology when you sort of like generate electricity from either wind, solar, and so on, and then you feed in the grid, like an ESCOM grid, and then you get some discount when you're buying your electricity and so on. We need now a new mathematical ideas that, to be able to deal with that. Interest rate reform, this one I have already said, interest rate reform, because interest rate models have been gone through a lot of dynamic. They need also a lot of new development. And then, of course, Herman, of course, is also working on this, and also AI and climate change. And so we need a lot of multiple K evaluation, hedging effectiveness. Hedging, that means you just want to mitigate your risk in the financial market. Yeah. I'm going to, so what we did, so last year, basically, we have done 2 big workshops where we invited more than 70 people each workshop. And then, of course, we had in these 2 workshops, we had like 3 to 4 international professors who were addressing. And then we also had, in total, we had about 10 seminars. And then also we have a lot of capacity building where we invite students from all the participating universities that are doing financial risk. We sponsor them, they come to Stellenbosch. Each master or PhD student has to do a presentation. And then we assign each student to a professor where they have one-on-one discussion in order to say, how can you grow in this kind of, in this area? We associate collaboration across institutions and industry, so with the policy. And of course, last year, last month, I published a paper on, it's a working paper, it's a sub-working paper, but this paper is peer-reviewed, and actually it's a policy document that tries to address, and if you want to, I can go technically into it. That's, with this new rate, this jump in this rate, so that means that in order to be able to model this rate, you must incorporate jump into the rate. But if you incorporate, there are some jumps that are actually scheduled. If the Reserve Bank is going to have a monetary policy meeting, of course, these are called the expected jump. But there are also some jumps that are unexpected. So you have to use a statistical tool that can able to detect the unscheduled jump. And this is what I've written in a working paper on at the sub currently. And it was well received. Even the governor actually wrote me, was asking some questions about the paper. So student development, of course, we give most of the funds, especially the industry-directed fund, because it's actually a lot of money, 2 million. So most of the chunk of this money we try to sponsor students, but we don't give a full bursary. So we rather give like maybe 50 students, and maybe we'll give each one 30,000. And so we use that to do training and mentoring across all the university. So sometimes the difficult, even I'm at Stellenbosch University, but sometimes I end up not even sponsoring any student from here because all the students are, they are paid off already. We don't give money to students, but we pay directly into their student account. Okay, research, of course, we have 10 working paper currently. We have 7 of them are submitted, and then we have about, I have to correct you, Prof. Francesco, we have 21 published papers. I can give you, already I can give you a spreadsheet on but we across, of course, we are just active associate, we're about 12 of us, but of course, 21 publication last year in 2025. I think this is good. I have to rush a little bit. So, and science engagement, we hosted Professor Robert Fuss from University of Bond University in Brisbane in Australia, and he is one of the well-respected Aussie academic, Australian academic, and he's a founder of Inspired Center for Research, the ICRS, and he hosted the Inspired Global Pitching Research Competition, which is the NITheCS chapter, which was hosted last year in September, and where people were submitting. Here we want to train any academic or any career researchers to be able to pitch their research. And this is actually very important in terms of like when you're applying for funding and so on. Even when you want to understand, just within 1,000 words, can you tell me what you're trying to solve? And it's a pitching research framework, and then he hosted it here, and some student, of course, won, and will proceed to the next stage. And of course, here, even here, so within our program, so now we use this pitching research framework in order for you to apply for, like, so I can take you serious that your research is serious. How can we fund your project that you're doing? So through the pitching research framework, Herman, you can, of course, you can attest to this, that we use the pitching research framework, not many pages, just one page, sort of, but we want to make sure that you are straight to the point on what you want to solve. And also, yep, so that means you demonstrate the idea, the pitch, and the project formulation. And that's what we are currently doing. Okay, well, I already said about the research that we are currently doing. The benchmark reform, I'm pretty much involved, and also Herman and your PhD student, we're doing this benchmark reform on Jaiba Zaronia. So now this is Johannesburg Interbank average rate, and this is coming to an end. There's a death of Jaiba, and then we have now the Zaronia that's coming into the picture, and everyone, I'm talking to academics, so you need to be serious about this because it will affect how everything works. It even affects your salary at university. So we have derivative pricing and volatility, and then we also have raw volatility, machine learning. This is machine learning surface. I think Herman, you're the one that's doing the surface. Also, I saw you also published a paper on this, and stress testing, market microstructure. Of course, the liquidity is another issue, and sustainable finance, climate risk. There's quite a lot of electricity market, hedging and risk transfer, and renewable is also one of the key alternative assets. And again, I'm very much, I'm big on these things to say that South African wine is actually can be considered as an alternative. And I'm serious. We published 4 articles in a proper peer-reviewed journal talking about fine wine, and I think I attracted a lot of academics. A lot of academics are actually very interested, and I'm actually this year I'm going to Perth, Australia, to give a plenary plenary talk on wine. South African wine. And what happened with this, there's actually a big organization called American Association for Wine Economists. And these are serious guys that meet every year at a particular point. Next year, I want to invite them to come to Stellenbosch. And we're working on, and there's actually a specialized journal called the Journal of Wine Economics. And this is publishing all the papers on wine. Okay, I have 5 minutes, but I'll manage to do that. But I mean, okay, of course, industry and engagement and data. But the problem is that the data that we get from industry normally has issues because industry, the appropriate data, so we can't really sort of expose the data, but of course we can just write a paper and then just make sure that so sometimes we even have to sign the NDAs, and in order for the industry to trust us in our research and to make sure that everything is okay. And yeah, so we're working with this COEF. This is the Center it's called the Center of Excellence of Financial Services, and Mark, he's the one that actually goes to the banks and gather research projects and then give us project, and then we send it to, so there's a lot. So this one I've already said, there's a lot of mathematics that need to be into model risk and so on. And I think I'll end up here, but I'll maybe talk about what's next. So we're hosting a workshop on interest rate reform and derivatives in April this year. And this is more on derivative pricing. We already invited Professor Robert Webb, and he's coming from University of Virginia in USA, and he will be the one talking about interest rate, and he is a specialist in derivatives market. And then also in September this year, we are hosting Professor Bart French. He's my boss at the Journal Futures Market, and because he's the editor-in-chief, and again, he will talk about derivative market design and emergence market application. And these are serious guys. Bart actually invited me last year in Auckland, and I was honored to be to give a plenary talk at their conference, which is called the Derivative Market Conference, that was hosted in Queenstown, and I had the opportunity to explore Queenstown, which was a privilege for me. And so this one I already said that we're working with the Center of Excellences. So what we do, we have a problem, we assign it to an associate lead for the project, we assign to a student, and then of course we check the milestone, and then also we want output. And again, I'm very serious on that, and we want to make sure that every project results in a peer review publication. I think I should really end up. There was a budget, but I think no need to. Okay, so we have two projects. One is the focal area, one is the IDRP. So the IDRP, they give us 2,000. So last year actually, because of the management of issues, so we employed someone, Nelly, and so we give Nelly sort of a contribution of 200 Rand. Then the publication, the article and proposal, we about 600,000. Student bursaries again 600,000. Workshop that we do here again about 350. And international conferences, this is when we're sponsoring students and also academics to go to workshop. Sorry, I think I underestimated my time, but I think I need to do this. And from the focal area of NITheCS, we got about 650. Of course, management fee here, because of course we know that NITheCS also doesn't have a lot of capacity like worker. So I hire sometimes a secretary in our department that able to do the buying of the flight and so on for for staff, and this one together I just gave 10,000 to her, and international conferences. So this one is the when an associate or a student also had to attend an international conference and also accommodation. Mostly major of this it was when I went to Sydney, Australia last year, and when I was invited at a quantitative method conference and also seminars and colloquium in here. Strategic sponsorship. We have this year actually we have a conference that's happening in Kruger National Park in Skukuza that's hosted by the Northwest University, and it's called Mathematics in Finance. And then these conferences we sponsor them 100,000 just because we want to mobilize the research activity in financial mathematics. I think I should really end up here. Okay, well, I think I should end up here. Really.
Other questions for Mesias, comments, and thank you for not complaining.
What are your next steps?
Okay, well, we continue working on the project, and of course, like I told you, there's 2 workshops that are happening in April and also in September. The problem is we want projects from industry, and then we also want to enable the collaborations within, But of course, I would appreciate like statistics, for instance, for us to have like a collaboration within NITheCSResearch Focus. We're very much open to that, or even computer science, because we need a lot of new thinking in how to model or to come up with, And again, I forgot to say this. I'm also an editor-in-chief for the Journal of South Africa. It's called South Africa Journal of Science. I'm an editor-in-chief mentee because Professor Wesley Swart is retiring at the end of this year. And of course, we want to make sure that we, especially from the natural science perspective, we need papers from there. Again, as an ambassador for the journal, and we want to make sure that we are aware of the journal, and then we also send these papers.
There's another question. So you also mentioned the engagement with data and that you have issues with data. I suppose there's also some persuasion that you have to do that you need other kind of data perhaps and perhaps is available through the industry. Is this something your research program is thinking about?
So, and again, the problem with the companies, sometimes they don't like to expose their data, but of course, what we do, we just want to work on the background. We will at least give, and again, it's very expensive. We also sign a memorandum of understanding with the Johannesburg Stock Exchange, but again, they want to sell the data, but it's very expensive.
So you see one part of your interaction with the community is actually persuading them.
One of my, and I'm very, very passionate about this. I talk a lot about the field. I want to make sure that the field is well acknowledged and the relevance of the field in the South African context is well appreciated. So that's one of my,
Please. So a lot of our students I have noticed that are going to work in banks, etc. So I'm a physicist, but a lot of our students are going to banks. FNB is hiring many, I don't know why. I'm saying that would it be possible from our side to have some collaboration between physics and finance? Of course, we should talk.
Let me tell you, I can go on and on and on, but physicists, there are actually a lot of, Herman, you're a physicist, but you went to R&D to work there. Of course, there's opportunity for someone from physics to actually go into the bank. Back then, so it was only accountant people, economics that works in the bank, but physicists graduate, even a PhD, couldn't get a job, but it was because of the problem that these guys were solving and then were stuck. And then a physicist is a security with a PhD, and so on. It's a way to do this. So there's actually a lot of applications.
A few days ago, I had a chat with the chief data officers of one of our top banks, and they are desperate for AI talent. And I hope to convince them to give us some money to develop AI talent. Yeah, but that's why I'm insisting.
Yeah, they are.
Yeah. They don't ask for They ask for statistics. They ask for AI. Yeah. So
Yep.
they'll do that.
Yeah, thank you.
I'm very grateful to Mesias because I attended some of his workshops, and there is really the who is who of banks in South Africa that takes part, and is happy to share problems and for solutions. And it would as the model that we should all aim at, yeah, to try to jointly reach out to not necessarily the SDI, but to other funders to raise additional funds. Yeah. Because he's the research focus area that has the most money.
And I struggle even to spend the money.
Some people don't. Don't say that.
You're inviting tips.
So please speak to Mesias and try to learn from him how he managed to pull it off. Yeah? Because it's really the model to go. You know, we should try to use the NRF DSCI funding to leverage other opportunities. Yeah? And we should try to do it together. Then it comes back to the community. Yeah? So Mesias, thank you very much. And next time bring a few wine bottles so that
Australia
from the index.
From the index, when you buy wine, my index is going up.
But you have to drink.
You have to drink.
Okay, the next, sorry, using your program, with from quantitative analysis to quantitative biology.
Ambassador.
You know, it's like, I just saw that AP. No, it's like that we have. He doesn't say anything.
No, I haven't had really any discussions with him about it. I think it's more like what elevation.
No, just after because I was
No, nothing. Because I like I wanted to
get it doesn't make dollars. Yeah, the noise is small. Yeah.
He's going to put through it. No, if you want something.
No, I agree. I think you'll have to just maybe.
Okay, perfect.
If I do see you next week, I'll.
How am I going to go back? Okay. Good afternoon. So I and Professor Kevin Duffy are going to jointly present this complexity in biological systems. So I'm the coordinator and Kevin is the deputy coordinator. And we, of course, have issues this year, logistics and capacities to access the funding. So lots of the activities actually are in kind because we have to carry on and move the research activities forward. So, but lots of the outputs carries NITheCS affiliation because it associates with that as secondary affiliation. In this focus area, we are trying to address a few challenges. Mainly it's social, economic, and social ecological type of issues. So the biological systems, and especially if we think biodiversity as a proxy of the biological system, is facing all sorts of issues. So it's also related to like climate change and also Earth system modeling. And we would like to address this using an interdisciplinary approach. And it aligns well with the SDGs. We don't need to go into the details. Okay, so this is our objective. So we would like to develop a set of things, and we build different kinds of models to especially target how we quantify, how we measure, how we forecast biodiversity changes, how can we advance environmental data science through AI and all sorts of data analytics. We want to integrate evolutionary game theories and all sorts of ecological theories, complex network theories into understanding the ecological, socio-economic systems. I keep mentioning the socio-economic, but Kevin gonna back me up later. So the main thing is to forecast how the biological systems will respond to different grand challenges, environmental challenges, such as biological invasions, climate change, and many other issues. And eventually we link this biodiversity changes to social, economic, including financial impacts, to inform policymakers. So we have 5 work packages. Work package 1 is ecological complexity and biodiversity. So it's kind of mainly model-driven model development. And the lead scientist is Sandra McFadden. Work package 2 is related to environmental and climate modeling. Priyanka is lead this work package. She's in the back if you want to chat with her. Chapter 3 is led by Ron Feldman. He's part of SAMBI, but it's also related at working at Stellenbosch actually. So his work package is related to data science and the relationship between biodiversity and society. And this one, Catharine is leading this work package 4, is related to animal behavior and movement. How can we learn from movement data to infer animal behaviors and then inform conservation policymakers and so on. And work package 5, we have coupled human natural systems using KwaZulu-Natal as a model system. I think, Kevin, do you want to mention the integrated, I think our next one is the integrated. So we have a set of deliverables, and I don't want to go into the details, but essentially we deliver through running workshops, collaborative workshops, focused workshops, student trainings, and also publications and so on. We don't want to go into the details, and the next is this, we want to give some brief explanation. Yeah.
Shall I just talk into this?
Yeah, maybe.
You hear me?
Okay.
I'll just talk loudly. So thanks, Cang, and good afternoon. Yeah, so the overall aim of R1 is to take this kind of approach and focus it on an actual system. And it's quite ambitious. And to be honest, we haven't really got going as such, but there's 2 ways to approach this in a modeling perspective, is to start building the actual model from the ground up, but you don't, or we're not going to prevent the individual approaches, which really go through all of what Cang has been talking about, but in particular our group. And we've got quite a broad group of people from hydrology right up to people in the municipality who are interested in actual social systems, agriculture, and people from mathematical modeling. So that's what's, and we're hoping this year to at least get some of the integration going. So I think that's all I'll say at this stage.
I think this is what the integrated framework is basically. Water and land resources, this is kind of related to Earth system modeling, yeah. So it's coupled with agri-ecosystems, and eventually it also impacts socioeconomic systems. And it's related to different sectors of the economy. But hopefully the work pact 5 will examine KwaZulu-Natal and see whether this system can be integrated system can be built up. So this is already listed in the progress report. So we have a list of micro mini schools, webinars, and the colloquiums, and we also have some involved students. Some of the, I think it's partially involved through NITheCS because we have issues, the logistic issues to access the support. So lots of those are basically supported in bulk by other programs. So these are just some photos. So most of the projects is actually supported through the SACHI program. We have a system biology program, we have animal movement workshop, we have team writing retreat, we have social insects, altruism, cooperation, altruism, we have dung beetles in Southern Africa, we have invasive wasps, we have morphological training offered by some past students, but now from Belgium, but now it's come back to South Africa. We also have the soundscape workshop led by US scientists, and they're basically running an NSF grant. So we partially support them to run this. This is another NSF grant, and NITheCS partially fund this one. That's on food webs, and this one is on soundscape. Basically, is what we hear and how we process the sound and so on. And this is also with UCT, SEEK, statistical ecology, and modeling, and we have interactions with UCT because the two universities is very close. And this is related to iNaturalist, which is the citizen science data platform, how we can access and use the data from iNaturalist. So next, I'm just gonna go through a list of publications we produced in 2025. And those are, so in a wider group, if I count, there are more than 70 publications, but I checked to make sure those ones has NITheCS in the affiliation. So those ones are reported in the progress report. In this one, so Sandra work package 1, so she is a part of this working group and is documenting the tree covers and densities in Kruger National Park. And they managed to record 27,000 trees in South Africa, in Kruger National Park, and map it and identify the drivers of tree cover changes in Kruger National Park. It's also in a very much related group. They documented changes in moths and mantises, also in Kruger National Park, and see how at different land systems and different seasons, how the invertebrate systems is changing, responding to seasonal changes, environmental changes. And in this one, I think they used the same data. They identified what are the key drivers, for instance, affect species richness, direct drivers, and the indirect and secondary drivers. And in this paper, basically, it's a consortium, global consortium. So that's why there are 145 authors, but including associates from our work packages with NITheCS. And so this paper is documenting like rhizosymbiosis. So basically it's trees and its symbionts, how the symbionts is facilitating forest growth and forest health. In this one, Pina is previous PhD student and is also in 2025, she was also a postdoc. Basically, this is part of her PhD project, is classifying and documenting ecotones. Ecotones are boundaries between different biomes in Africa. So we're also closely collaborating with Leeds University and also Lincoln University in New Zealand, and we hope to actually working on ongoing grant applications on the same topics with Leeds University and Kew Gardens in UK. And this one is a quite interesting group. So it's WIO, West Indies Ocean Group. So they have a Norwegian research vessel and prowling the shore for the last 20 to 30 years. And we managed to access the data through a consortium based at Catharine, shown. So, and then we can project species richness, the rarity, and we can map it. So they are using this for regional conservation planning at the moment, and there will still be some ongoing research. South Africa is only just part of here. In this work, it's Suleiman is also a previous PhD student, and Peter and me are both supervisors. We are both associates. And this is related to how thermal reaction norms, so it's kind of a thermal plasticity responding to climate change, to environmental changes. So for instance, some insects can survive between 10 degrees and 30 degrees, and there is a performance curve. So this performance curve can adaptively responding to environmental challenges in fluctuating environment. So the shape of the curve will change. So we are studying the adaptive evolution of this, the shape of the curve. Yeah. In this paper, so I'm teamed up with, so this Melissa is a PhD student, Adrian is a Canadian research chair. So we teamed up with essentially all Canadians plus some colleagues from Israel, and we try to design a quantitative approach to infer interactions between bacteria in gut. It's related to gut microbiota. And so we designed this approach, we call that dynamic covariance mapping. Because you have numerous bacterial species, and to infer its interaction strength, it's nearly impossible. We have to use the dynamics. So each bacterial species, their counts are fluctuating, it has a trajectories. We use this covariance structures trying to infer the strength of interactions, also whether it's positive or negative. Claudia, this is part of her master thesis. Karen is the current director of AIMS. So we work together in this MSc project. As basically, we want to partition something like this. So in lots of ecological data, we have this site by species matrix, this type of things. So this indicates whether a species is presence or absence in a particular site. Now we want to quantify, we want to partition those sites. We want to group them, and they represent something very similar in terms of species composition and so on. So in this project, Claudia identified that this forms a Boolean semi-ring, and using the Q-ideal approach, the ideal approach, we managed to partition the rows, which is species compositions and so on. So she is currently doing a PhD on a very similar project with expanded topic. In this paper, it's a group of we are part of this UK NERC grant. So where is James? So James Roger was my postdoc, and we're both in this Glitterous project. And in this review, basically, we proposed this integrated approach to combine, to utilize different evidence types to infer insect dynamics, insect declines, or essentially is insect declines. And James also, after this, he is now a senior lecturer at Slovakia University. So he's also part of the social NITheCS associates. And in this work, this is related to another European Horizon project we are running together with some colleagues in Europe, with 11 universities in Europe. We are a core partner of this grant. So Christian is a PhD student. Luke and Dave are two colleagues that I worked with in this project, is basically documenting, designing a workflow to identify alien plant species in Western Cape urban area. And biological invasions, of course, because I'm also part of the Center for Invasion Biology, is a major issue. And this is part of the consortium that contributed to the IPBES invasive species and impact assessment. So in this basically collective review, we basically documented, presented unequivocal evidence that biological invasions is on the rise. It hasn't plateaued yet. So we have to wait and see what more species is rising. And actually lots of collaboration is ongoing in this field. For instance, just within South Africa, we have all our South African IPBES team. We work together to assess the thematic assessment report. What does that mean to South Africa invasive species monitoring and risk assessment? So there are also other projects ongoing. So this is also another global consortium. We're using space for time substitution because we can't wait to 20 years later to see what's going to happen. So we use spatial gradient to assume that can be translated into temporal dynamics so that we can project what is the future. So this is kind of compare the present and the future for different life zones. And of course, in lots of biodiversity research, we need data. So this is the side project. I and Jan Hendrik, he is a previous PhD, but he's running his own companies now. So we live nearby. This is Anglo-American at Somerset West. So this is 1 hectare. We divided this into 2,500 plots. And he spent 8 months to collect all the plant species. Each plot in 8 months told me this was also going to be his last project. No one spent 8 months. But the data is openly accessible. We are using this data for student trainings and also designing workshops this year to explore what are the plant community assembly rules and patterns and so on. This is another consortium called GUBEC, Global Urban Biological Invasion Consortium. So this consortium is essentially initiated between CIB and the Canada University of Toronto. And Mark Caudette is from there. So after this, we had a back and forth meetings, and then eventually we had a number of meetings, rotating meetings, And this is out of data set that collated from all the partners contributing to it. And eventually it document 553 urban centers from 61 countries. What are the alien plant species list for those urban centers? And we also have ongoing animal movement research. So this is a short article published by Alison, and she is actually partially funded by NITheCS for maybe not for 2025, but for 2024. So Catharine is running work package 4. So her project, her PhD project that she's submitting this year, so it's working on the conservation of lions, the lion movement between Kruger National Park and Limpopo National Park in Mozambique. And we have telemetry data of about 22 lions. We can follow the trajectories and we can identify the behavior, the movement strategies, and after which we can inform the conservation management in the national parks and where are the poaching events, and we can at least do a proactive conservation planning. Next, and there are a few papers also by Kevin. I'm just going to ask Kevin to.
2 minutes.
Yeah.
I'll try to get through it. So to say again, the idea is to focus KwaZulu-Natal and create a focused type of model. We haven't got going on that, and I'm not going to belabor this, but the realist fault it was we didn't get any money. So we didn't start on that. But if, I don't know how well you know KwaZulu-Natal, but one of their major crops is sugarcane. And as much as I'm against that morally, for 2 reasons, it's not nutritious and it's bad for the environment. But disease in crops will be an important thing for the overall model of KwaZulu-Natal. And here we quantified the effect of disease. How do I go forward? Just push it.
Yeah.
Okay. I'm going to skip that one for now. Oops. Oh, down from me. Sorry. And as Cang was saying, invasion's another very important issue. And this is, if anybody's been to any, hands up, anyone been to KwaZulu, Shishlui Game Reserve? Okay. And if you know your species at all, you'll see huge swathes of this Lantana camara. And it's a big issue in natural ecosystems. And here we show how you can use simple modeling to quantify it. And in fact, we're developing this research further to show how it can affect the natural biodiversity of a system. So let's go back to this other one. It was mentioned of this guy, your top researcher. He's a good friend, and I collaborated with him on this. So if you look at the traditional ODE type of modeling, where you're looking at a dynamic model, we just show how it is possible to reformulate it as a mechanical model. And this work also is, we just showed an example. But using this method, we're now developing some work where we can show tipping points in the environment where the mechanical approach is very appropriate to show these kind of tipping points. And then you go back to this whole idea of crops. If we did manage to get it right, and we had this great model, and don't get me wrong, I don't think it's going to be that simple. Then at the other extreme, we've got some research showing that amongst our very nutritious, poor population. There are crops that should be grown instead of sugarcane, for instance. And this is about using legumes. And then here's an example of where we integrate two types of issues, food security and disease in the crops, and show the trade-offs between the two. So as I say, at this stage, we just carried on a bit like Cang has talked about, just carried on trying to do some work that should lead to some integration. And we're hoping very soon start from the bottom up and have a model basis. Thank you.
Well, there is a. We also announced there is this world conference of natural resource modeling, which happened this end of this June at Stellenbosch. So both me and Kevin are part of the local organizing committee, and we actually would like to see whether NITheCS can co-fund just partially to support South African participants to travel to Stellenbosch. Because the international ones, they have registration fees, everything sorted. So that's, yeah, that's us.
Question for Kevin and Ken? We're running a bit late.
So these are really amazing projects, and of course very close in many cases to also policy and policy makers. What advice do you have for the rest of us in how persuasive one can be to policymakers, especially in the light that there seems to be a trend to be very skeptical about certain kind of modeling in international politics?
Yeah, especially
how does one do this successfully?
Yeah, I think in South Africa, you have to closely involve those agencies that are basically they're directly funded by the government. SANBI, Scion, like NITheCS is also one of it. So actually work with NITheCS, get us closer to policymakers. And for the international ones, because the international one, the European Union, they design those programs are intended for policymakers. So the project has to be packaged into policy briefings. So in each EU Commission meetings, we send in like 1 page, just like a sketch of what we recommend that you should do in specific things. And it's signed off by 30, 40 scientists from 12 institutes, leading institutes in Europe. So then the policymakers might consider that. But it's you have to keep lobbying. It's demand not lessen at all. Yeah. So, but I think you have to have those communicators that are sitting in between science and the policy making, so they can, like, as a bridge, or yeah, for the project.
Any other questions or comments? Okay. Please, Monica, you're welcome to unmute and speak.
Yes. Good afternoon. It's been a long day for the biologists waiting for the biologist talk. But anyway, thank you so much to everyone. And then to you, I think you're talking about bridging the gap between policy and what you're doing in monitoring biological systems. I think there's probably an opportunity to discuss with SANBI. I saw that SANBI was your collaborator, but from my side in SANBI Pretoria, where we sit, where we participate in meetings at the CPD level, where we have to do policy briefs for either climate change, for the One Health, issues. And I've seen that you have got projects that are looking at the disease, invasive species. So all of those, I think there's a need maybe to have a discussion and see how we can help you to bridge that gap, or find people within this space who are looking for that information for their policy briefs. So yes, I was impressed with the scope of work. It touches on most of the things we do in SANBI. I think And it's great that this is happening within NITheCS. And then from my side, as part of the NITheCS, committee and everything, and FANB, yes, we would be able to discuss and I think find avenues for you to be able to do those policy briefs or to have input into those meetings. Thanks.
Yeah, I think Monica mentioned something very interesting, relevant actually. So, our group, not my group, but there's a group, like every Friday we have a stakeholder meeting. So I think this is also a stakeholder meeting. But in that stakeholder meeting, we invited actual not just the participants, you're in the research, but like city managers and conservation agencies. All of those, even like some informed citizens, they also want to participate to discuss specific issues and see how the research can inform and help them, and so on. But it's very difficult. So you have to through this type of dialogue. There is no formal channels for this type of communication. You have to establish this type of stakeholder dialogue to kind of put in the idea. Yeah.
Excellent. No, thank you very much. The advice. If NITheCS can help invite more stakeholders, just let us know. Okay, I think now it's mathematics showtime. Zurab, please. Yeah.
Yes.
Is your Prof something?
My NITheCS website.
Who was there?
We need to share this now so that it's visible there. No, it's better. That's fine. Good. I would actually like to begin how one usually would have ended such a talk, to thank not just NITheCS, but specifically Francesco for taking such a good care of the entire NITheCS community. And through his hard and dedicated work, we are able to have access to various opportunities that NITheCS provides. And yeah, I think we have a very humble and gentle director. So whenever he suggests that something we could do, I think we should take it seriously. And so one thing we took seriously is to put the website on the new website. NITheCS has a new website, and we've populated information on the mathematical structures focus area page on that website. And in fact, I want to show this to everybody. And so the presentation will be the web page. If you go to the focus areas, it's not the web page's fault, it's the computer's fault, I think, because if I click here, nothing happens. We try again. I think I need some, oh, there we go, okay. And then you will see here a list of focus areas, and the one I'm coordinating here with Maggie as deputy coordinator is this one, Mathematical Structures for Foundations and Innovation. I was initially a bit skeptical of the new technology that's used to design a website like this. Eventually, I discovered it's one of the best that I've ever seen.
All right, so I don't know why the computer is a bit slow, but I hope that will be fine. So you will see these tabs, and each part of the presentation will be going a bit through these tabs. Maybe here under About, I will highlight 3 overall big goals we have in the focus area, which is to explore fundamental mathematical structures, foster interdisciplinary structural insight. This is actually one of the defining aspects of our focus area. Usually research in mathematics is conducted in mathematical silos. There's a very intricate structure of subdisciplines and sub-subdisciplines and sub-sub-subdisciplines. So what we try to achieve in this focus area, in light of the overall spirit of NITheCS of interdisciplinary research, we try to bring all the subdisciplines together, and once that is successfully achieved, then start truly interdisciplinary mathematical investigation as well. And then, of course, in this process, developing future researchers is in fact one of the key outputs that we would like to have from the focus area. Another homework that Maggie and I took very seriously when Francesco gave it to us at the discussion with the focus area coordinators last year, or was it the beginning of this year or something of those lines, was to formulate the grand challenge for the focus area. This is, I must say, still work in progress, but at least this is the first version, and then you should tell us, Francesco, if you're happy with this first version or not. And also everybody else, if it sounds relevant and sounds accurate. So the formulation of our grand challenge is here, it appears in italics: to uncover and elucidate mathematical structures central to future innovation in mathematics and human development, strengthening human and research capacity, and positioning South Africa and Africa as a global leader in the generation of foundational mathematical ideas. That's the grand challenge for our focus area for the time being. There's a bit more one can expand on this. These 2 paragraphs were written specifically for non-scientists, maybe for the government or the funders. Hopefully that will be useful at some point. Let me tell you a little bit about the coordinating team. Initially, when we formulated the application for the focus area, we were told, as everybody else, to dream big. So we asked for 6 million rands a year. And of course, we know that we only got 650 last year. So we had to be a bit creative. What are we going to do with the big team we had initially that consisted of more than 60 mathematicians? How are we going to manage that? And we actually took this structuring of the focus area quite seriously, given that the focus area is about structures. We arrived to the following structure. We have decided to have the work packages representing large classes of different kinds of mathematical structures, still that share some commonality. So we've got a work package on discrete structures that includes things like graphs and number systems and so on. And then we've got a work package on analytical structures and one on algebraic structures. For instance, Hilbert spaces and vector spaces. Well, vector spaces would be on the algebraic side. Hilbert spaces could be on the border between the two. So these are not supposed to be disjoint sets. These are supposed to be different angles, sort of, and many of us in the focus area function in several of these work packages. And then we've got categorical structures and topological structures, and each of them has a person that oversees the work in that work package, and such person is also a member of the coordinating team. We've got 2 coordinating assistants, Professor Eric Andriantiana from Rhodes University, Dr. Sirin Ratilal from University of KwaZulu-Natal. Maggie is Aphane, Professor Maggie Aphane from Sefako Makgago Health Sciences University is our deputy coordinator. We're very grateful that she accepted to join us as the deputy coordinator, because
She is extremely busy, head of department at her university, and doing remarkable things at her university, which keeps her very busy. So really grateful that she joined us. And I'm the coordinator, and we also introduced one other layer of making sure that we make right decisions. We have a scientific chair. So whatever we decide, scientific chair needs to approve that. Scientific chair is not the one who is involved in coming up with ideas what to decide, but he needs to tell us if he feels that we're on the right track. So this is kind of quality control before we go to Francesco for our decision, with our decisions. So that's very useful, very nice team, by the way. Already last year we started this, but this year we're more systematic about this. We meet once every week. We have a coordinating team meeting, not a very long one, where we make plans and discuss how and what to use funds for and so on. Another thing that we are doing for our focus area is this book. So when our time expires, we will leave a book that contains all the things we've ever done in the focus area, including details of mathematical achievements as well as activities and other things highlighting the innovation that came through the research and so on. So this is a working document. We're editing it on the overleaf. I will not take you there. I've shown you here the cover page of the book. The design sort of feels a bit chaotic at the outer level, but is very precise at the when you zoom in. So there are perfect cubes there, right? But when you zoom out, you see those cubes are not quite in a homogeneous state. And that kind of reflects the spirit of mathematics, where mathematics is a very formal subject, it's very precise at the ground level. But when you want to do something big, it's no longer so precise anymore. It becomes much like any other science. Let me now tell you about a few highlights from 2025, which I think is the main purpose of the presentation. Let me begin with numbers. 15 published papers, 15 papers submitted for publication, 15 postgraduate students, and 15 presentations. This is a deliberate approximation, so this is not exactly 15. Some of them are 16, others are 14, but I thought it would be prettier if all of them were 15. Sorry?
You planned where 15?
Yes, that's exactly what that was kind of well, sometimes it's not very, it's difficult to count sometimes because it's a big team and right. So before going into the discussion of the highlights, let me mention that among the coordinating team, some of us are on the editorial boards of 4 international journals in mathematics, of which 2 journals are Q1 journals. And most of us have NRF ratings. There's someone with P1 rating. On the side of the algebraic structures work package, Morto Goswami has done really a fantastic job in that area. He has furthered collaborations on algebraic structures in various ways. One such collaboration is with Professor David Blecher, who is actually a functional analyst, but he's an open-minded functional analyst, so he enjoys interactions with mathematicians in other subdisciplines. And so there was a very successful project that they did together. In fact, David Blecher is formerly South African. He often visits South Africa, but he's permanently at the University of Houston. Another collaboration is with Vaino Shambwa, who is from Namibia. He visited us, Vaino visited us, and also Morto visited while he was visiting so that we could work on a project together, which we did, and it was quite successful, and the paper has since been submitted for publication. Another point to note was that Morto gave his first talk at an international conference on algebraic structures in Austria. And that was a very nice development because the organizers of the conference are lead experts in their field,
and they've approached Amorto for some refereeing tasks. And then they mentioned to him that we have a conference in Austria, don't you want to come and give a talk there? And he did just that, and so he was able to expand his network by visiting Austria. In fact, 12 papers are co-authored by him that were published in 2025, so he's quite a prolific mathematician as well. He was also promoted to associate professor because of that. Analytical structures. Originally, this was a work package that was led by Wenqi Guo, who has really done amazing work last year, but she felt that she's overcommitted this year. She kind of pulled out from being on the coordinating team, and we're hoping that Maggie will take her place in overseeing research done around analytical structures. But this is something I haven't even talked to Maggie yet about this, so we'll see about that. But one thing that when she did while she was still with us was to organize this conference on ordered structures with applications, which was partially funded from NITheCS, and it brought some researchers from other African countries, specifically Tunisia, and that was quite successful. Functional analysis, by the way, is one of the biggest and strongest research groups in South Africa in mathematics. So it was very, very nice to have this connection with them through Wenqi. But we'll continue that through Maggie as well. Categorical structures, this is where I am the person that oversees this team. We have actually some good news on the Stellenbosch side. We've expanded our research group. We have 2 new appointments in the department who are essentially category theorists. One of them was, in fact, a postdoc in physics with Francesco. So he's, in addition to category theorist, is also a physicist, partially. Kishan Dairam, and then Emma Taird, who was a PhD student, is now also appointed to Stellenbosch, and that was very nice to have that. So this is a picture from a seminar in our research group where we invited a colleague from UK who visited us, and we are working on a very exciting project which is going to have quite substantial international resonance, I hope. The discrete structures team is led by Eric, Andrea and Tana. They had a 3-day research and writing retreat in January at Begueni in the Eastern Cape. They're working on some very interesting problems, a very innovative topic as well. In fact, the entire topic grew out from his collaboration with Zacharia Shozi, who is a South African mathematician. And the next steps for us is to get this topic to be heard by the international community as well. So one of the things we want to do in our focus area is to cultivate innovative ideas and then try to get international attention to them. Topological structures is led by Dr. Siri Ratrilal. There were some further new collaborations there as well. She also traveled quite a lot and gave a few talks in various places, including Max Planck Institute in Germany. And then as a way of supporting the wider mathematical community, we joined in on the venture of a historic meeting with the London Mathematical Society and the South African Mathematical Society and the Southern African Mathematical Sciences Association. This was the first meeting of this kind. And what we did was those mathematicians who were in our original focus area application, we supported those who wanted to attend this conference to go there, not just go there, but also give a presentation on what they do. It was really a networking event, and it was a quite successful one. A number of collaborations grew out from that event. The president of LMS was there. I was, that time, president of SAMS, hosting him together with the president of Southern African Mathematical Sciences Association. And there is a website also, if you're interested to look exactly what we did during the conference, you can look at that, and there are also follow-up discussions about collaborations with UK and LMS, joint PhD students and so on. Then we had a mathematical structures workshop held at Stellenbosch. The goal of this workshop, this was shortly after we recruited Professor Aphane in her role as the deputy coordinator. And one of the things we're brainstorming together with her is what kind of impact can this focus area have on mathematics at HDIs. And so we had a kind of experimental workshop where a number of staff and students from her university, from Mahato Health Science University, visited. And it was really a very nice encounter. We had student presentations. We gave feedback to the students on their presentations. We had research brainstorming sessions. We even came up with some interesting ideas for applying insights on mathematical structures beyond their existing applications. And then we also wanted to do an excursion, but we were told that we can't use NITheCS money for that. We should just use it for work, not for fun. So we came up with a wonderful idea to do something that would not require a lot of money. We went to Table View, and that turned out to be an extreme success. It was absolutely minimal cost excursion where we played soccer. I played soccer on the beach for the first time. Not soccer, sorry.
Volleyball.
Volleyball. I don't even know the name. I played volleyball on the beach for the first time in my life. And the students were also quite happy. We were laughing together and running together and all sorts of things. So that was a very pleasant experience. And in terms of our science engagement, we have this thing we call the Future Mathematicians Program that was initiated even before the focus area when we had a research program similar to our current focus area. And the idea there is to make an impact on teaching and learning of mathematics in a way that supports structural thinking, in a way that supports the kind of thinking that one needs for engaging in their future lives in a research of the sort that our focus area represents. So one of the things we did last year in this direction was to be part of the Mega Mathematics Festival that was held at the University of Western Cape. It was a collaboration with South African Mathematics Foundation. They kindly gave us a slot for the Future Mathematicians program where we could present the work we're doing in this program, and it was very, very well received. Many new connections have also been made there. And finally, in the scope of science engagement, we also, as many of you know, we also take it to a bit of an extreme and do mathematical theater. And so you can, if you miss the theater, you can go on the website and check it out. But I'm not going to play it now. It's a two-hour production. You will see some of the mathematicians here playing music and doing philosophy on the theatrical stage. Now I've lost my slides there. Okay, there we go. I would now like to ask Maggie to tell us, yeah, just a few minutes. Tell us about, is it fine with the, yeah. To tell us about the, what are the needs of HDIs? What can NITheCS do for HDIs, and what can HDIs do for NITheCS? Could we please load the presentation?
Which presentation is that?
I think I gave you a USB stick.
Oh, yeah.
I think this one's tricky. There's a one here. Places. So maybe there's something. It's almost 3. Why are you guys still keep?
Okay. Thank you very much. Good afternoon, everyone. What a wonderful day. I was so enjoying when I was listening to all the presentations, and NITheCS is doing a very great work. And myself and Professor Zurab, we just decided that it is only when you know what people don't have for you to be able to assist them. And this is the opportunity that I feel that we felt that at least if we can share with you from one of the historically disadvantaged university, Sefako Makgatho Health Science University, we think that one day us as well, we will love to sit here and share with you how NITheCS has pushed us to be somewhere. It's not everybody who knows what is Sefako Makgatho Health Science University, where is it based. So now, I will start by providing you with some institutions, including Sefako Makgatho, which are historically disadvantaged institutions. Those universities, it was not by fault. They are called historically disadvantaged because of how they were created and the situations there. They were specifically meant for Black and colored Indian students during that apartheid regime, and we are one of those. And for you to is that the situation did not change. We are still in that circumstances, whether the university was born in 76 or 80 something, the situation did not change. So Sefako Makgatho is one of those institutions. Now, even if we are under that historically disadvantaged institution, the government tried to change the name, but the circumstance did not change. So initially, as we were called Medunsa, which was given birth in 1976. And then from Medunsa, there was a marriage, University of Limpopo, and then there was a divorce. That is when now we were called Sefako Makgatho Health Science University. But for your information is that even there were some marriage, there was no new infrastructure. So the building is still that the ones that was from 1976. So you could understand the environment and also how we are surviving. Now, where are we based? We are based in Harangua, that is Pretoria. Our objective is still to support and get a good quality education, but the challenges are there, and the challenges will never change overnight. Now, from the challenges, before I give you the challenges, I will give you the background of the department. I'm the HOD for Mathematics and Applied Mathematics. Have you ever thought of a department that does not have an associate professor or a professor? That has to produce undergraduate, BSc, honors, masters, and PhD. I'm the only associate professor in the department, and I just recently got my associate professor. So the department has been running without that person, but we should produce the masters, the PhD graduates. Now, since the birth of this department, the department has been there from Medunsa, UL, and also SMU. We produced our first PhD graduate last year in May. I joined SMU in 2019. When I joined SMU in 2019, the department was having 2 honors students in pure mathematics and 5 in applied. We produced our last master's in 2011. So the situation is real. And this is what we are living with. But we don't want to sit back and say, no, we are historically disadvantaged. But we are saying, NITheCS, this is us. With all the challenges that we have, we need help. What type of help? Is only when we inform you that this is the situation. How do you expect the department with only 4 PhD holders? The 2 are recent. When I talk about research, they got the PhD 2 years ago to produce a PhD student, to produce a master's. You have a program, ECP up to PhD for maths and also for applied mathematics. That is the reality. Now we are saying, though the challenges are there, even if we've got shortage of staff members, we are able to do the submission. We managed to get our first NGM, a lecturer, which started last year in August. We managed to have at least one postdoctoral. We did the submission, we were able to get, we applied through NRF, we were able to get one. So this are at least the good news that we do. But we submit a lot, we got rejection. Because some of the requirement does not suit us. They will need an associate or a full professor, a rated. Do we have those? No, we don't have. But we are still an institution. So we are saying to NITheCS, you are doing a great job. May you also look at the HDIs. We are not saying we should get things easier, but let us know the situation and see how NITheCS can come to us. What is it that we need? We will also love to have postdoctoral. We know very well that NITheCS has got these resources. And then we are saying, plea to NITheCS, at least from your 10 postdoctoral, may you consider the HDIs. At least provide 4 for HDI or 6, whatever. Do we have research assistant? I don't even have one. I only have one postdoc. If I may ask, Prof. Zurab from your university, how many postdocs do you have? We apply through COMAS, we got 0. We apply for other NGAP, we're getting 0. So I'm saying, if there is a need for all the HDIs to come together and put the challenges that they have, and also what they will love to have from NITheCS, the help that they can get. I am willing to call all the HDIs and have a meeting so that we can put. It will be nice for us one day to say, this is where we come from. This is how NITheCS has helped us. Now, these are the challenges that we have. A lack of seminar rooms, smart lecturers like these ones, postgraduate rooms, computer labs, ICT, with the proper facilities, libraries. We will love to have new programs, but do I have manpower? I don't have manpower, but I don't want to sit and complain. What I want is to get a support. Whatever support that we can get, we will also love to have BSc Actuarial Science and other new programs, okay? That is why when we came here last year, we were able to engage with people like Prof. Zurab and also Prof. Eric. Currently, the graph theory group now, they will be visiting SMU so that at least we can build that, have that niche area being developed. If I'm not a graph theorist, it does not mean that the department must not have a graph theory group. Through the help of other institutions and through the help of NITheCS, we can be able to introduce that. We are trying our best. Despite all the challenges that we have, we are trying to get that. Bursaries for our postgrad and our undergrad. When I was listening to the engagement, you said that you will top up for research assistant. They don't have bursary. Where do we top up? But we still have to produce the master's and the PhD student. What is it that we will wish to have? To strengthen the research capacity, enhance academic productivity, and promote sustainable scholar development within the department. The following strategic support initiatives are proposed. Funding and recruitment for postdoctoral fellow, as I've mentioned. If NITheCS will be able to assist, at least to put the HDI and say at least 6 for the HDI, let it be one of the targets from NITheCS. A research assistant, visiting researchers or retired professors. We will love to have those people. Because how do you produce a PhD? The university has got a clause that your PhD must be older than this for you to be supervised. We have found ourselves in that. Okay? Mathematical software. The number of postgrad is increasing. There is no way you can continue to work. You will need to have an overleaf, a simple software, so that at least you will be able to supervise more than 2 for a postgrad student. The staff replacement cost, the academic excellence, and generate a meaningful benefit. So this is what we thought that colleagues from our HDI, we are saying, if possible, we can even organize a meeting, and then I believe that they will present also their challenges, but this was a background from Sefako Makatra Science University. Thank you very much.
Just one last sentence, one sentence. So we talked about what NITheCS can do for HDI universities, and what about backwards? And the answer to that is talent. They have students. Since Maggie has joined that university, the postgraduate student numbers are no longer where they were. They've increased quite considerably. She did an amazing job in that. So there is a lot of students that are keen to learn more mathematics, more physics, and so on. And so that's what HDIs can give back to NITheCS, the talented young students.
Very much.
Thank you. Status now. Quick questions for Maggie and Zurab, please.
An excellent talk, Zurab. I think you know that Amartya Goswami came from University of Zululand, and he actually joined us while I was head, while he was still working on his PhD. And he completed his PhD, and we trained him so well that he did his PhD in applied mathematics, essentially. And then, we trained him so well that, as you can see, the position that he is now, just aside. But what I wanted to ask is, regarding mathematics and so-called applied mathematics, if you want to differentiate that way, there was one stage, and there are still many universities which essentially have only applied mathematicians, very few pure mathematicians. But now the situation seems to be changing. In your opinion, how do you think this is happening? And do you see really sort of a very great future for mathematicians as compared to applied mathematicians?
To be honest, well, being in my shoes of the president of the Mathematics Society for the last 4 years, I don't really like this differentiation between pure and applied mathematics. I think mathematicians can have various interests. They can be more interested in applied side. They can be more interested in the pure side, and this can also vary. Like, for example, myself, I've always been very interested in pure mathematics, not as much in applied, but now I'm developing interest in an applied side, and maybe in a few years I will also be in applied. So what I'm trying to say is that I don't think we should think in this division, in terms of the division. I think we should rather unite. And what I like about NITheCS is that there is no such division at NITheCS. We have a theme of mathematics. It doesn't say separately pure mathematics or separately applied mathematics. So my answer to your question is strength is in unity.
Maybe one more question.
Yeah, or we can discuss later. I guess those about the website. Who is maintaining it for your focus area, and how much time does it take? Like, is it a big investment of it?
I'm maintaining it. I'm very experienced in maintaining websites, and this new system is incredibly helpful. It doesn't take any time at all. It also even helps you like organize your thoughts. So it's a.
And what happens to 2025 kind of news when next year? Do they go into the booklet that you like?
It's already in the booklet.
Okay. And so
it's already, in fact, it's the other way around. First we do the booklet, and then when we are asked for the report, we copy paste the information from there. Yeah. Yeah. The book takes a bit longer to maintain, but it's worth it.
It's worth it.
No, I loaded Mesias earlier for the raising of funds, and I want to load Zurab for the website. Yeah.
Well, it's very
nice. All of you should learn from Zurab how to run the website. Because we made at the end of last year the transition from WordPress to Plone. Plone is an open source content management system. It's designed to be easy to upload and manage complex content systems. And we just gave Zurab the user ID and password, and he learned it himself. So
there is actually
if he's a computer science genius.
There is actually an anecdote there. So they gave me username and password, but they forgot to give me access for some of the parts of editing the website. And I didn't realize that. I got back to them and told them, this is the worst experience of website editing I've ever had. And the response was, this is the worst feedback we've ever received. And then they said, okay, but we forgot to give you the access, and now you have the access. And after that, my experience completely changed. So after today, I'm gonna write an email back. This is the best website editing experience I've ever had.
It's really very easy. It's very intuitive and very easy. And maybe we should organize a seminar, a crash course, how to edit the website so that everybody.
That's a good idea, yeah.
And maybe at the end in the discussion, I can reply to you because I think we're running a little bit late now. And break now. And we can meet again in 15 minutes, maybe 4:05. We'll continue with one of the metrics to astrophysics.
I think I promised to take care of the website for our. Sorry.
I really like your passport password.
It's super. If you don't mind, just
Yeah.
They can't hear me. Okay. They haven't missed much. Okay. So this is kind of the overview. I am going to do my very best to keep the science introduction short, though I confess that that's what I find most interesting. Then I'll talk a little bit about, why I think it's quite important for us to be investing in these areas as we currently are. And then probably more along, what you might have had in mind for today is to talk about developments that have been happening in the recent past, so sort of 2024, 2025, telling you what we're currently doing within these themes and within these sub-themes of our focus area, and then maybe a glimpse ahead of where we should be going with this. So this is me starting out the introduction. We can actually just skip right to it. If you've seen a talk by me that's sort of the introductory nature, it's likely that you might have seen the slide, because I do quite like thinking about why this type of science even is interesting and why it allows us to do quite fundamental physics that we can't otherwise get to, things that we can't reproduce in a lab very easily. And so what I'm showing you here is a neutron star. It's spinning, it's emitting radio beams from its magnetic axes. And I've put up some properties here that are well known. And as you can see, they're sort of just here in everyday English. But these properties I can distill into sort of very foundational or fundamental concepts that allow me to then use them as space-time probes or as probes that I can use to test physics with. And so that's what I like to think about, is that, sure, this is a neutron star spinning, but it's also just a point mass because it's so small, it's only 10 kilometers across, it's so ultra dense that I'm not resolving it with my telescope. I just have a perfect point mass up in space. Because it has these exotic densities, because I've essentially squashed 10 times the density of any sort of standard atom on Earth into the core of the neutron star, I'm looking at exotic matter. So this is where nuclear physicists get really exciting, is what is really going in the core of this neutron star. It's material that needs new physics descriptions. It's got an incredibly strong gravitational field. So this is where some of my work lives, is that means we've got really warped space-time. That means we can start doing interesting tests of gravity in the strong field regime, where we can really start to see whether theories like general relativity will break down or not. And then on the other hand side here, we're seeing the properties that make them observable to us, that allow us essentially to do this work. The pulsar is going to emit these radio beams that I've showed to you before. I don't think this pointer is pointing. Here you can see the yellow emission. This is going to have to travel through the interstellar medium before I actually get to observe my spinning neutron star. So it passes through a medium, and that means it can tell me something about the medium it's passed through. So that's super helpful. But probably the most important property here is that I've got this incredibly dense, rapidly spinning compact object that spins so stable that I can rely on this to be turned into a clock in space-time. And of course, once you've got clocks in curved space-time, you'd be able to do interesting physics experiments. So that's one of the main properties you'll see come up in my slides as we continue, is how do we use the properties of these accurate clocks up in space to do interesting research. And the last thing, actually, maybe this is the most interesting one that sneaks in here, because we're really only starting to get good at this now, is how can we actually expand this? How can we start using neutron stars to become gravitational wavelengths? So that's the first intro. I'm going to quickly take you to, if I now have a very fast spinning clock in a curved space-time, how am I actually able to time it so precisely that it becomes a useful instrument to me? So that'll be sort of one slide, and then we'll just think about some of the applications very briefly. So this is the one slide, possibly too colorful, but here we've got a pulsar. In a very basic sense, we're going to say, okay, this thing is stably rotating, so I'm just going to see a pulse with a constant period. That's great. the system is going to lose kinetic energy, so if the pulses are actually over time going to come at a slower rate, so I can find some pure derivative, I can find some spin down rate. And the things that are a little bit under rug swept in this talk is, and then there's everything that the interstellar medium does to my pulses to make them harder to actually count. But if I had a good model to say, as the star is spinning, can I count every emission that comes out? If I had a good model and I said, oh, that's pulse number 15,311, and that's the one after, if I have such a model, I can switch on my telescope, I can have the pulses stream in onto the telescope, and I can just double check how well my model has done. And so, as with many experiments, here what I'm plotting is when I expected a particular pulse to arrive from a particular neutron star up in the sky versus when it then actually did arrive. And you can see if I'm doing really, really well, then the difference here is far less than a millisecond per pulse. So that's kind of the basic game is when you discover a new pulsar, this is not where you're at. This is where you're at after you've done years of work. You can get to this point where I very accurately know when the next pulse is going to arrive. This problem becomes more interesting if you have a binary system. So now, all of a sudden, quite typically, we find neutron stars, compact objects, in orbit with other compact objects. This is a white dwarf. That's a very classic binary to be observing. This pulsar is in orbit with its companion. And now, all of a sudden, when exactly this pulse arrives at my Meerkat telescope, for example, is truly going to depend on all the orbital properties. So this means I can find some of these exciting properties. I can start to see what is the orbital period. That's pretty easy. After a few months of observing, you'll start seeing sinusoids in your residuals that you can fit for. You can start seeing other basic things like the projected size of the orbit. I'll soon tell you how we can think about getting the mass of the companion out of these types of experiments. But for now, the idea is just to say that you can start getting some basic Keplerian parameters just by switching on your telescope and seeing these pulses stream in. So that's pulsar timing in a nutshell. There's a lot more to it, but the things that are the most fun to say in talks like this is here is a pulsar. It's called 1909. It's very well known in my community because it's one of the most stable timers we have. It's got a spin period of roughly 3 milliseconds. And to give you a sense of how well these types of experiments work, is that given that I've known this pulsar for a very long time, I've been timing and watching its pulse periods come in for a very long time, I can therefore tell you that the eccentricity of the binary, it's in a compact, it's in an orbit with a white dwarf companion, it's very nearly circular. So eccentricity here, just a reminder, 0 would give you a perfect circle. 1 is a straight line. That's the other side of the extreme. And so 10 to the minus 7 here is a fractional parameter that tells you that this is a very circular system. The orbital size is about 570,000 kilometers, but I can measure and I don't want to put my head on a block, but I can be very assured that the difference between the semi-major and the semi-minor axis is only 2.7 microns. This is nuts because the system is 10 to the minus 16 kilometers away up in the Milky Way. But just because I can count, so here's an example of counting the pulses from this pulsar since the first observation in 1984 until the most recent observation is obviously a lie because I should be standing here and updating my slides. But at any given point, I can, without any error, tell you what number of pulse has arrived to my telescope. And it's because of this phase coherent solution, in other words, I never miss a beat, that I can start making ridiculous statements like this orbit has a difference between its two axes of only 2.7 microns. And I guess this is to illustrate the power of what type of experiments you can do with such accurate tools. Okay, so this gets me to, you now know what a pulsar is, you now know the basic idea that we can time them, and you now hopefully know that it's likely, given their extreme properties, that we could do interesting physics. And so these two themes of experiments I'm going to explain to you in a little bit more detail now, because that's also a strong focus of our current research group. I've briefly mentioned to you that if I have a pulsar in a binary orbit, that pretty quickly I can get the basic Keplerian parameters. So I can look at it and I can see. So you can imagine that if you have the position of your pulsar wrong, you'll get some sinusoid in your residuals. If you have the orbital period somehow wrong, you'll get some residuals, and you can fit for these things until you know them very well. That you can do within 6 months, say. If you continue timing these sources for a long time, you can get to all these post-Keplerian parameters. So these now become expansions of the Keplerian parameters, and they have to be described by some gravity theory. And so here, for example, if I just assume that general relativity holds, then these will be evolutions of some of the Keplerian parameters. And you can see that they are again expressed in terms of simple Keplerian parameters. So that's orbital period, that's eccentricity, and there's some masses in there. So what I want you to see is that if I time the pulsar in a binary for long enough, I can see things like orbital precession. So in other words, the same effect that we see for Mercury, but now highly exaggerated. So you can see how this orbit moves across the sky in degrees per year. That's the omega dot here. You can see that the orbit is shrinking. That's your PV dot. And this is the famous experiment that gave us this first indirect detection of gravitational waves. So the orbit is shrinking over time. That's what the derivative here. And then maybe let me point out R and S. These are shape and range parameters of the Shapiro delay. And this is a fun one because it's when the pulsar is behind the companion. For you to see the pulsar, its emission has to pass through the compact space-time around the white dwarf, or whatever its compact companion is. And so that passage through the well of that space-time will cause a delay in your signal. If it's not in superior conjunction, if it's like this, you don't see that delay. But the moment you're behind the companion, you actually see that this light has to travel through a curved space-time. And that shows up very beautifully in our pulsar timing experiments. The one thing I want to point out as well, I don't think I'll go into too much detail in this talk, but all of these effects that I can see in my residuals over time, or in my timing model over time, depend on the pulsar mass and the companion mass. So this means you can come up with ways to actually compute what is the mass of a neutron star very accurately. And this becomes important because we don't really understand what exactly a neutron star is made of, and especially what its interior composition is. So if you can find a neutron star with some ginormous, ridiculous mass, that will really challenge our theoretical understanding, for example. So that's one of the exciting type of experiments. And here I'm just showing you that these things are genuinely, truly happening. This is our Meerkat telescope looking at the very famous double pulsar. There's only one such system that we know of, where it's a pulsar in orbit with another neutron star, but I can see, or at least I used to be able to see, emission from both of these stars. So a double whammy where you get emission from both of your neutron stars. And what I'm showing you here is that same type of plot where I'm plotting the difference between when my timing model thought the pulse should arrive at my telescope and when it actually did. It's the difference. So here I'm doing badly if it's away from zero. If I'm at zero, it means my timing model is correct. And I'm doing this on purpose to show to you when this is Shapiro conjunction. When my pulsar is behind its companion, the signature is delayed by 100 microseconds because it's passing through that curved space-time. So this is data taken in, I think, 22 by now. And we did a detailed analysis of the how to interpret the eclipsing behavior of this pulsar that you can see in this 2024 paper by Marcus Lower. Okay, how fast am I going? Perhaps for the same system, this double neutron star system, this double pulsar system, the only one for which we've got two pulsars, this one was famously used for the first very highly precise test of whether general relativity holds just by using these expressions that I showed you before. So imagine you can see the effect of these in your residuals. So you can see how your timing is off because of the impact of these parameters. Given that all of them just depend on the two masses, you can say, I'm going to plot the mass of the one pulsar here. This is in units of solar mass, right? So 1 is the mass of our sun. I'm going to plot the mass of the neutron star here, and I'm going to plot the mass of the other neutron star here. And each of those curves, as you remember from the equations, depended on M1 and M2. So surely every neutron star only has one unique mass. So for the theory of, if the theory that you're plotting is standard general relativity, then it needs to be the case that they all intersect in only one single point so that you've got unique masses in your system. Otherwise, something's odd. So this was done way back in 2006 already. This is the updated Meerkat result. Looks incredible. You can't see, the lines have been thickened so that you can see the lines. If you plot them with the error bars as is, or with the error bars representing the size of the line, you can't really see the plot at all. So that's enlarged, and you can see the intersection for these parameters incredibly well. And essentially, the system tells us that GR agrees to within 0.01% of the predicted theory. The measurement agrees to within 0.01% of the prediction. Okay, so that's kind of the scene of relativistic binaries. That's just the start. There's a lot more that you can do. But I want to use some of my time to tell you about this, which I think is probably the most important question in this particular research at the moment. And that is, how can we expand this idea of using clocks in space-time to search for gravitational waves? And this, as you'll remember from the focus area, this is a strong sub-theme within our focus area, is to be detecting, analyzing, and understanding gravitational waves. And the things that I'm involved with most just got to do with, detecting them using pulsar timing arrays. So the experiment is conceptually very straightforward. So I suspect some people in the audience will already have heard of the LIGO detections, the direct detections of gravitational waves. For those systems, essentially what happened is we built a detector on Earth with 2 arms. Each of the arms were 4 kilometers long. And this means once you've placed the detector, you kind of have a sense of what's the wavelength you can measure, right? So if you're building something that's 4 kilometers long, then you're going to be sensitive to wavelengths that are quasi-kilometers long. So the astrophysical objects that LIGO is sensitive to is when you've got 2 solar mass or tens of solar mass black holes in spiraling. They'll give off gravitational waves. The gravitational wavelength will be such that you measure it with something that you can build on the planet. But the moment you've got galaxies merging, this no longer holds, right? So now you've got most galaxies have got supermassive black holes at the center. If I've got galaxies merging, I've got a much larger system merging, and the wavelength that I expect, the gravitational wavelength that I expect to be coming off these is of the order light years. So now I can't build anything that can measure a wave that has the size of parsecs or light years or millions of kilometers. So I need the galaxy itself. So essentially what we do is we say, all these pulsars that I know so very well and that I've timed so very well, I'm going to use them as my detector. And if the gravitational wave passes through these clocks, it will perturb the clocks in such a way that hopefully I can predict that a gravitational wave with a very long and slow wavelength has passed through the system. So it's nice to make artist impressions of this stuff. It's a little bit harder to actually find the gravitational wave. This is the science really started taking off sort of in the, I guess, early 2020s. People were starting to see some common signatures. It was still all a little bit hush-hush and not clear at what point the detection will become more clear. And this here was just a reminder again for what, what frequency of gravitational wave we are hoping to see. The original hush-hush measurements and then later less hush-hush was to say that the first thing that I will become sensitive to if I'm trying to detect these gravitational waves is just the fact that there's going to be some background from all the galaxies that have ever merged across the age of the universe. They're going to cause a stochastic background, and this stochastic background is going to have a particular frequency dependence. And so if I see this as like a common signal in all of my pulsars, just from a frequency perspective, then maybe I've seen the gravitational wave. So that was sort of the early investigations. But the real smoking gun is if you can show how your sensitivity to the signal depends on the separation of any pulsar pair in the sky. So gravitational waves, if you take the standard general relativity theory, has got two polarizations, the cross polarization, the plus and the cross polarization. And you should just think of this as if you have a ring of particles and the gravitational wave is coming through, it's going to disturb those particles in a very predictable way. So if the thing that's being disturbed is the pulsar that I know so well, if they are in the same line of sight, they'll be perturbed in the same way. But if they're 180 degrees apart, they'll also be perturbed in the same way. And if they're 90 degrees apart, they'll be less correlated. So this is what the famous Eddington curve tells you is, dependent upon the angle between any pair of pulsars in the sky, I should know how correlated when they lose their clockwork, I should know which ones should be losing their clockwork in the same way. So I won't go into the details, but this really is the smoking gun to say I have seen a gravitational wave background from all the pulsar pairs that I'm observing in the sky. Okay, so that's the science background. I hope that sort of gives us enough language to talk about some of the rest of the things that I want to talk about, which is more to do with where are we now, what's happening now, what are we doing, and why should we be doing these things. And so that's tick box one, is that it is really because of the extreme properties of neutron stars that we get to do exceptional science, and that sort of the scientific potential is what we're after. This is something we don't want to miss out on. It's not something that we dreamt of. It's something that's quite recognized in the astrophysics community. So if you look at how the Meerkat telescope, for example, awarded hours on its instrument, two programs, MeerTime, which was to time known pulsars, and TRAPPIST, which was to find new pulsars. They were priority 1 and 2, and together they were awarded more than 6,000 hours on this telescope. There were only 8 LSPs, so this is 2 of the 8 LSPs, and by far the largest fraction of awarded time. And we're doing well in terms of getting results out of those. So maybe just also to see the timeline here, this was the start of the Meerkat telescope. So that's sort of the first 5 years, and you can see we're now just out of it. So it also now matters to think, what does the world look like beyond these large survey programs that have finished observing? Okay, so why do we invest in this? Yeah, I guess this is just to say, even if you hate astrophysics, these results are often quite remarkable and lead to high flying publications. So one of the works that I found quite exciting was a binary that we timed in a globular cluster. And for this particular case, because I've shown you can get masses out of these binaries, we found a neutron star, we found a pulsar and emitting neutron star with in a binary with a compact object, but we can't quite tell if this is the heaviest neutron star ever or the lightest black hole, and we'll just have to wait and see. And this paper shows very nicely that the mass has a too large error bar to say now, but it kind of lives exactly higher than a typical neutron star and lower than a classic black hole. So that was one of the research highlights I wanted to show, the kind of dates sort of in that early era of MeerTime TRAPPIST programs. And then now we're coming closer and closer to current time. So June 2023 was a moment when several collaborations across the globe decided to, on the same day, reveal their evidences for this background gravitational wave. So the way this works is that there are different pulsar timing array experiments across the globe. People have been timing their favorite pulsars for decades. And so then finally, the Europeans, the Indians, they actually combined their results. The Australians, this is the Parkes telescope results. Nanograv is the American result that used to use Arecibo and the GBT telescope. So all of them jointly on this day published their individual increased evidences for this stochastic gravitational wave background. And the thing to keep an eye out for when you actually read the science papers is that everybody's just saying increased evidence. This was not yet a detection. This is saying it's hard to make the signal go away at this point, but it's not a 5 sigma detection. It is increased evidence. So that was June 2023, and a reminder that these folks are all working with data that spans at least a decade. That's what their curves look like. You might not be impressed, but it's the start. Just over a year later in terms of where we presented it for the first time, but shortly after, in sort of a science lifetime, Meerkat, using only 4.5 years of data, unveiled its own detection. And the strength here is that we're monitoring a much larger population of pulsars, so 83 of them, and we have incredibly sensitivity through our telescope. So the errors on our little measurements are a lot smaller. So this is by far the shortest data set in which anybody has ever claimed to see evidence for this detection. So that was exciting. We used the IAU, IAU meeting. The General Assembly was held in August last year, and that opportunity was used to showcase this result. That's the paper that shows it. There's a little blurb from UCT's website. So this all sort of happened, the publication, there was advanced access to the publication in December 2024, and then the paper is dated January 2025. And so, I guess again, this is not why we do the work, but it's just to show that, these are works that gather citations very rapidly for being, and you can see it's really these three because they were the first claims. We're a bit later, and so the citations there is still growing, but this is the type of stuff that get people excited, because now we can start to ask the next questions about what does this all mean, and is the signature truly just the Hellings Downs, or is there signs of other things in there? And so I'll now explain to you a little bit what we've been doing in the last 2 years here in South Africa. So at the end of 2023, together with 4 colleagues of mine, we started thinking about putting together our own PTA group. And at the start of last year, we started the African Pulsar Timing Group, APT. And so in our terms of reference, the leadership positions run for 2 years. And so we've just re-elected the positions for 2026 and 2027. And this was really just us trying to make sure that we have a local footprint. There's a lot of people, international collaborators of ours, of course, that use the Meerkat data and that do incredible science with it, and we're a part of that. But we wanted to make sure that there is something that's very local and very relevant to students here. And so the APT, this African Pulsar Timing Group, also tries to cut across just doing searches for gravitational waves, but also other types of pulsar science. So this is what we look like at the moment. And again, just a reminder, I'm simply expressing what's been happening in this focus area within one theme within our focus area that I've been highly involved in. These are our students, and I'll just say that I am incredibly lucky to have a whole bunch of highly talented students working with me. So Atik, my PhD student, maintains this website for us, so you can see more of what's happening in the pulsar timing community there if you want. We jointly created some logos. That's a subgroup of us at the end of year Soraya Bursary Conference. And so it's really been nice to see how much they're enjoying working as a group. Venu's not pictured here because he was writing up his PhD. But Venu has been my honor student and has now finished his PhD. And I think to him it's bizarre because he was always the only one, and now there's actually so many people that he can interact with that it's just super great. Okay, so the biggest news, I guess, in all of this is that by April last year, we became official members of the international collaboration, so this IPTA. And as the chair of the APT, that means I sit on the steering committee of the IPTA. And essentially, this is just pulsar timing array experiments realizing that because of that correlation with angular separation, you need northern and southern hemisphere telescopes to work together. That is by far going to be your most sensitive data set. Even though we're all very competitive and it's all very political, we want to work together, and that is going to be the data set that produces the best result. And so we were voted in as members in April 2025. That means we are now part of their working groups, etc. And it also means that we are part of the roster hosting their annual meetings. So yeah, maybe just for time, I'll skip over this. This is a bunch of telescopes that do the work. These are all the groups. We're the latest member. And essentially, I guess, the ongoing research is what I can't dive into because I love highlighting students' projects. They work so hard. They're so into what they're doing. They have access to the most spectacular data. I'm so jealous. And yeah, this is the group at UCT. There's, well, sorry, let me go one back. I just want to show some of this you'll start recognizing. Jay, my postdoc, is really working on a very interesting, highly relativistic binary, doing these GR tests. Atik is trying to model these HD curves, but adding alternative polarizations, so not just GR polarizations, adding some non-Einsteinian modes to that. And I'm the PI together with collaborators from especially Max Planck Institute in Bonn of a program, a large observing program on Meerkat that's going to continue observing these double neutron star systems. So it's really just a plug for their fantastic work. Venu, the other PhD student I mentioned who's just submitted his thesis, he's discovered new pulsars in the LMC, by far the largest discovery by any single survey to date. So he's got his 2 papers out and he's just submitted his thesis, and we may have discovered the very first binary in the LMC, in the Large Magellanic Clouds as well. Christu, he's the vice chair of the APT. His group historically has done a lot of high energy physics modeling or high energy modeling of neutron stars, and are really starting to bring in radio data as well. So this has been a super collaboration to do this multi-wavelength work with. And I know that it's getting late, so these are the people that if you're at Salamos, you might recognize. They work closer to the cosmology application of this, trying to use pulsar data to also understand if we can find dark matter and things like this. And I'm only skipping because I know I've been talking for a while, because the last bit I want to say to you, which is probably the most exciting bit and where I'm really thankful for NITheCS, is that not only have we joined the IPTA and does that make us a part of hosting these grand annual meetings, we now have to do it, and we have to do it very soon. It's happening in June this year. And we really wanted to put together an affordable and a distinctly South African meeting that is not in the Western Cape, just for reasons that we've had many meetings across the community in the Western Cape. And so the meeting that's about to happen is the IPTA 2026. This will be in the Drakensberg and Alpine Heath. We have had fantastic support from NITheCS to get this organized, so thank you for that. And what is incredible about this conference is that it always has a 1-week student program before you go into the science conference. And that's a very good training program for students that want to do this type of work. So you can see more. Again, this is Atik, my PhD student, maintaining the websites. Super grateful for that. And you can just see all the things we're planning. And that's a master student, again, designing logos. So they're all so helpful and excited. And so I'll end here to say thanks. And just to remind you that this is the flavor of what's happening in transient science in this focused area, but that there's also a lot of other things that I'm just not equipped to speak about. Thank you.
Other questions for Marisa?
Can I ask a question to Anselin? do you want to, would you like to say, I spoke to Ansel and Arun just before this and just wondered, given that you're in the audience, if there was something you wanted to add.
Well, it was a very nice presentation. Just a quick comment. We're one of the work packages within the focus area, and we run a very good workshop in Geyer. That was now completion for Marisa, and we that was connected to the NITheCS supported. We'll probably have one again this year.
Thanks.
So one of the challenges and also mission of the focus areas is to get the work packages kind of collaborate with each other. How are you managing that in your focus area? If you have, if you are managing and if yes, then you can share some insights from yours.
Okay. So firstly, I guess I get to cop out of this because I'm not the program coordinator, and I guess from my experience in working in the themes that I'm working in, some of them collaborate very easily, right? You can hardly care about a neutron star's mass before you accidentally start doing PTA work. It's very, it's in good overlap. But then I think there are other areas where